All right. Can everyone hear me? Let me just make sure the whole screen is showing. Yep, looks like it is. While I'm waiting for people to file in, I thought I would maybe casually go over some of the stuff I did last week. Some of it on stream, but I did a bunch of work afterwards. So if you guys were watching, I think it was last Sunday, I was working on this thing called Sino. What's this? I was working on this thing called Sino, which started. I called it a foreign data and function interface. It started as essentially a way to describe C-style data structures and also to access them according to that structure. So you have obviously primitive types, int8s, uint16s, whatever, floats, doubles, but you also have aggregates like structures and unions. You have pointers and so on, and also function pointers, although that's a later addition maybe I'll get to. So yeah, so I went through the development of that last time. One of sort of the nice API design elements here is that there's a get element pointer style interface. If you guys are familiar with the LLVM instruction set, it's kind of like that, where you can traverse arrays and structures and stuff like that in order to get to the fields. So I went through that last time. The thing I started on last time, but um, I wasn't quite. Hey Sam. I wasn't quite able to make progress on stream because my x64, my knowledge of x64 calling conventions on Windows was really mediocre, and kind of stumbling through them on stream was not really workable. So I went offline and read up and did some experiments and figured it out pretty quickly. And so I finished that basically off stream, and maybe I'll go through it a little bit now. But basically, the idea is that you can take so I have an example here. You can take something like a function defined in C or any other language that follows the standard calling conventions, and it can have any types of arguments, value type arguments, pointer arguments, built-in types, aggregate types, whatever, both for the parameters and the return values, and then you can basically, using sort of this type schema system, you can describe the type of that thing, and then you can kind of call it dynamically, and it will, according to the type signature, it will figure out what the calling conventions are, how to pack all the data into registers or copy it on the stack if need be, etc. And we'll sort of marshal that in and out. And so that's what Sino call does. It basically has two parts. It has a C part and an assembly part. The C part is responsible for basically parsing the types involved, the type schemas, and preparing, deciding whether to put things in registers or on the stack according to the x64 Windows calling conventions. And so it basically does that. If you guys haven't seen this before, the basic logic is if you're passing a value type that's less than or equal to 8 bytes in size, then we pass them directly in registers. If they're greater than that, then we have to copy them onto the stack, and instead of passing them by value, we pass them by pointer. So there's still a temporary copy of that value, but it's on the stack. It's not in the register. So there's no convention for like splitting value types across multiple registers or something for efficiency. As soon as you're dealing with more than 8 bytes of structured data, it always gets copied on the stack and passed by pointer, which, by the way, is kind of an um, interesting point when people talk about sort of, I guess, performance optimizations related to value types, is that there is actually on x64 by default, there's a lot of this copying going on, even if you think you're passing kind of by value. There's still a pointer in direction. Anyway, so it does all that stuff, and so that's the first part of it, and then the second part of it is like there's only 4 arguments that can be passed in registers, and anything above that have to be passed on the stack. So that's the second half of it. But anyway, so this function just basically builds a sort of a call context that describes the where what values go on the stack, which values go in registers, and then once it's prepared that, it calls this Sino Win64 call, and that's the thing I wrote in assembly language, and I think you have to write in assembly language, which basically takes this struct, which is a mirror of a C struct, about what's the function pointer you're calling? What do you want to put in the first four registers? What do you want to put on the stack for the arguments? And then all this function really does is it essentially just unpacks that struct data into the corresponding registers. So for example, the first argument goes in RCX if it's an integer. Well, it goes in XMM0 if it's a float, or RCX if it's not, which is an integer or aggregate data that's been packed into an 8-byte integer, and so on. And then this is like the stack copy for the temporaries, and finally it does the call and moves the return values into the struct and restores the state of the stack and returns. So anyway, so I did this stuff. Works well, not as fast as I would want it to be right now because there's a bunch of work, so I could streamline a bunch of this. I think right now, if you do a C function call, like of a very small function that doesn't do a lot of its own work, so basically the only thing you're measuring is, well, let's see here, is pure, let's run this thing, I guess. Okay, that one doesn't actually do the measurements. I guess that was this one. Oh, and this isn't debugged. Let's just run it in release just so guys can see the numbers. So I guess this is like 2.5 million function calls of this getPy function. If I do it using my foreign function library, it takes 85 milliseconds. If I just do the call directly, I think it takes something like, oh yeah, oh, this was a really bad case. So this is like a worst case. If you do this, nah, let's not fuck with that right now because I have to change a bunch of stuff. But anyway, for like something like a function that only takes one argument, because a lot of the marshalling overhead is per argument. For a function that takes one argument, I think I'm like 15 times slower than a native C call. It gets worse though for this kind of stress case where you just have a bunch of arguments that in this case don't really serve a purpose. But anyway, like I was hoping to get it within 10x, and I'm pretty sure I can get it there if I just restructure things a little bit. But anyway, this all works. So with this, we have basically a complete foreign function and foreign data interface. So you don't need to. I don't know if you guys ever looked at libffi or things like that, but this is basically a replacement for that, at least for x64. So anyway. I guess I'll move on to the media library. I just wanted to, while waiting for people to show up, to go over some stuff that I didn't do on stream last time. So yeah. All right. Mu. Yeah, so I had this idea for a while about a different way of designing the API of a sort of an SDL-like platform library designed for multimedia. So Sean mentioned that his platform layer has like, a lot of virtual memory, coolness, and async and I/O features. I'm not necessarily thinking so much of that. I'm like, if you wanted a complete layer, you would probably need something like that. I'm mostly just thinking about kind of media stuff. So basic window stuff, not complete like window management features. Um, Input handling, obviously, graphics and sound are the basics. Um, and my motivation for looking into it, I mean, is twofold. One of them was that if you look at a lot of the pre-existing libraries, they're just really huge. So I think SDL is something like, even as a DLL, I think it's almost a megabyte. Maybe I'm wrong about that, but it's certainly hundreds of kilobytes at the very least. If you look at other libraries, they're even bigger. So SDL is not even like in that class of libraries that are sort of like the kitchen sink platform libraries. SDL is definitely not like, but is not one of the worst offenders in terms of just having large binary bloat. Um, there are others like SFML that have a bunch of third-party libraries linked in by default, and they're just sort of huge. So one of the motivations was, let's make something like honestly the main thing I care about is Windows. So if I can just make it small on Windows and go from there, I'll kind of feel confident that I can keep things under control. Um, and so that was one of the motivations, is just to make something that does what I care about, basically, that's not too bloated. Um, and the other thing is I wanted to try a new API design. So one gripe I have with a lot of media libraries is that they require too much specification of basically default values. Yeah, so right, so like what Sam is describing, that sounds about right. Like it shouldn't have to be more than that, and that's even with a lot of features. But yeah, so anyway, one of the things I wanted to do is I wanted to play with a new style of API design. Um, so the standard way of doing these libraries is that you have a lot of functions, right? So you may have some kind of context struct that describes like a an SDL context or whatever. I guess in SDL's case, there's actually a global. There's only an implicit context when you do SDL init. But there's some sort of context either explicitly or implicitly, and then you call a bunch of functions to access the different things you care about. So like, is a button pressed? What's the state of where's the mouse cursor currently? What's the current delta time? Um, all these different things. They're always sort of function oriented. And because of that, it's also really inconvenient to pass like any one of those functions will tend to return like a single base type, like an int or something. Because if you're returning multiple things, then you kind of have to put them into a struct, and then as the caller of a function, I have to unpack it from that struct to get at it. And so it ends up being this very sort of granular thing. It's just kind of awkward to deal with. So that got me thinking, what if you had an API that basically gave you everything you wanted, or at least everything I kind of wanted, or 90% of what I wanted, like the majority of what I care about, but there's basically no functions. It's all data. And so that was sort of the impetus. And then from that, I started, I started sketching basically. I still haven't implemented anything. I'm going to do that on stream, I guess. But I started sort of sketching some ideas. And so let me just start doing that before I even start implementing something. Um, so let's see. Um, so yeah, okay, I should probably include Windows. So yeah, so sort of my basic idea was, and this is very superficial, but it kind of gets at it. So first off, here's what I want for my basic. Um, Here's what I want for a minimalistic game loop that kind of does nothing. So this is basically like a two-function API. It essentially does the minimal thing. There's an initialization point where you create the main window, set up frame buffers, set up audio buffers, whatever. Then there's an update point where maybe you do a swap buffers, maybe you push out your sound buffers, and so on. Um, Although essentially what this means is what I call the push-pull model, which is this. So really what update does is um, is two things in one. It does push and then pull. And so initialize implicitly also does a pull at the end. But the basic model is this sort of aggregate push-pull model where at the beginning of the frame, you pull all the various external state, like you sample all the external devices, real or virtual, right? Like just think of all the different things that are connected that you're interested in interacting with. You pull all their most recent state into the mu context struct. Then you run your code based on that. And your code based on that won't call functions. It will just basically grab stuff directly out of the mu struct. And then at the end, you do a push, which essentially does the opposite. So, for example, maybe it does a swap buffers, maybe it pushes out some audio buffers, and stuff like that. It does any updates that need to be done. But even that actually can be pushed. Like I said, you can merge this into this one function called update, um, which does sort of both in one. So basically, update does a push and then a pull to prepare for the next frame. So okay, so that's very superficially one of the ideas behind the API. So what does that imply about this struct? Well, this struct you can almost think of as just containing like a crap load of almost global variables that may or may not be pertinent to what you want to do. So for example, um, you may have uh, you may have a bool which is quit, and so this is just the most trivial example to complete what's needed for this toy loop. is there's a flag that can be set to quit if some high level thing causes the quit event to happen. So for example, in Windows that would be like pressing the X button or pressing Alt F4 or something like that. Um, okay, so D7 Samurai says that's how my API is. I call that pull stage gather. Yeah. Okay. So that's cool. So I hadn't seen anything quite like this before. I would say, by the way, the proximate if you guys have ever done sort of IMUI type stuff, it's a little bit like that where you're not. I mean, it's not the only way to do IMUI, but one of the easy way to do it is to sort of have a lot of global state you're just pulling from directly. And that's constant throughout the frame. You're not even calling functions; you're just pulling that state directly. So that's sort of the idea, but you're doing it in a pretty aggressive way that I hope to show. The other thing, by the way, that this thing allows is a nice way of doing default parameters for initialization. So, for example, you will probably have like something like a title, or let's call it a name. You'll have, let's see here. You're going to have you're going to have like window size and position and stuff like that. And the other nice thing about sort of putting everything in one struct is that you have this convention that basically all these initialization parameters, when they're zero initialized, they mean like do the reasonable default thing. One thing that always annoys me about a lot of other APIs is that just default initializing them is like a needless pain in the ass. So this is sort of another benefit of just having this mega struct that is used both for sort of giving input to the API through default parameters or whatever, but also reading back in this push stage. But anyway, so yeah, so that's like, so for example, let me just see. Sorry, this is a little bit incoherent. I haven't really prepared anything to talk about, but let me give you a bunch of examples of stuff that specifically I've been considering for this. So for window things, for example, the position is something that you would, if I wanted to set the position to be like at a specific value at init time, I would just set it here. But in addition, this is also an output parameter because at any given point in this struct, if I want to print the current value of the position, I would also just do this. So it's that sort of, you see it sometimes in the Win32 API where a given struct is both used for input and output. So that's the idea here too for a lot of these things. So yeah, so that would be it for Windows state. Now another example that would be kind of interesting. I mean, it's kind of trivial, but I think it's sort of a neat little thing you can do. Is consider delta time, right? So inside a game loop, you're often wanting to sample delta time, and one nice thing about having this mega struct is that you can expose all kinds of parameters that are like pre-computed to be convenient values that you're likely to need. So rather than just having delta timer in maybe in QPF units, you're actually pre-computing them in a bunch of different units that maybe someone would want to use. So for example, you have maybe delta nanoseconds, delta microseconds, and delta milliseconds. And maybe you even also have delta seconds and floats for people that want to use that for whatever reason. For deltas, using floats is not the greatest sin, right? But yeah, by having this kind of mega struct, it's really easy to just pre-compute at update time all these different redundant but ultimately very convenient representations of the same stuff. So that's something that becomes really convenient with this kind of mega struct thing. So yeah, so that's one example. Here's another one. Oh, so let me talk about event handling, because I think this is one of the things that the traditional way of doing event handling in something like SDL is like would be something like this. You would probably do it like this, and you would have like there's a mu event, and you would do process event. You do something like this. Now I don't think there's anything hugely wrong with this, but compare this kind of approach to the way that X input works. So if you go to the, let's see, x input get state, I think it's called. If you go to this function, if you go to this function, this essentially just gives you the current state of the controller. Now, what this means is that if you want to get you basically have to sample. You have to call this function at a high interval, otherwise you're going to miss events. But you can make a very strong argument that if you're doing a real-time application, you need to be doing that anyway. So you can kind of take this approach and apply it more broadly to event handling. So for example, let's see. So for keyboard handling, first off, let's make a digital button. And a digital button has, it can be down, which represents what's the current state. It can be pressed, which represents an edge condition. And so this means it goes from not down to down, and this means it went from down to not down. So that's how I would define a digital button. And then for a keyboard, you would say keyboard is an array of digital buttons, and or maybe we call it keys. And let's just say 256. So that's what a keyboard would be like. And let's say it would be indexed by scan codes, which is normally what I want to. What was I saying? Yeah, normally for games you probably want scan codes. Well, I guess it depends. But for something like WASD, you definitely want scan codes. So yeah, you can do something like this, and then when you want, instead of doing this style of like while pop event handling, at any point in your code, and again, it doesn't have to be like where the events are being handled. It can be anywhere. You can just say if mu keys, and let's say you can use ASCII codes for the sake of example. If this is pressed, then do some shit. So you can do it like this, and you can also say, you know, if y is down, then you do something like this would happen whenever, as long as it's being held down. So you can do this kind of stuff. So yeah, so you would do this for let's see, you would do this for normal keyboard input. Now what about text input? So text input is a little bit. So what's your suggestion, Tom? Store button states as the count of frames the button has been down for, or negative if the button is up. I see. Yeah, that's an interesting idea. Maybe I'll explore that later. I think I'll just go with my initial conception for the sake of discussion. So what was I? This is keyboard state. What about text input? Okay, so the one case where I would say that this kind of sampling approach is a little error prone is for text input, and one reason is for text input, even if you're running at 30 frames a second, for example, I don't know. Like I guess it's really hard to actually type at that rate where the sampling becomes an issue. But also just for the sake of processing convenience, rather than using an event style API for this, it seems like the best way to do it is essentially just have something like this. Might as well set this to 255 as well, 256. And then, you know, in here you can. Oh, and the convention is 0 if no new text. And then you can just do like this. If mu text, you can do like this. So for text input, it captures, like, even if there's multiple keystrokes between the samples, it will capture the sequence, and it will also do any translation that needs to happen from, you know, from key events to text events. Sorry. Okay. What's another example of this style of API? Sound. Oh, so this is maybe another interesting case of this stuff. Um, okay, so for sound, really what you want to do, um, let's see. Sorry, this is really scattershot. I literally just have, okay, let's see here. How do you deal with the situation where the UI grab keystrokes and the game shouldn't receive them? If I type W into a text box, my character shouldn't start walking since both of those read from the same keys array. Um, brum, brum, brum. Okay, game shouldn't receive them. Yeah, I think maybe what I would say for that is I'll have to think about that actually. Let's not get bogged down in that. That's a good point. I can think of various ways you could address that. One of them is to say that there's a way of suppressing key events for things that match text. Like you can basically, no, I guess it doesn't really work with this whole model. Let me think about that. I do think you can make that work without perverting the whole idea. Let's just keep going because I had a bunch of ideas in my head I want to get out before we start kind of iterating on the details. So the other one I was thinking of is sound. So here's how I would like to do sound, just from the point of view of the API user. What I want to say is, let's see. But basically what I want to be able to do is, um, there's a sample rate, um, and let's assume, okay, so there's a sample rate, and this could be, 44.4 kilohertz or something like that. Um, there's a sample buffer, and we're just going to assume that this is N16. So there's a sample buffer, and this will be like max samples. And this is sort of the interesting trick. Points to beginning of sample buffer at after update. Um, so yeah, so the idea with the following is this. Every frame I want to be able to basically just say, oh, and here's the other thing. So we set a sample rate, and you can fill this in yourself, I guess, at init time. Otherwise, it'll just be filled in with a default. Um, and actually, instead of calling it sample rate, which is ambiguous, let's call it samples per second. So this would be actual 44K, not hertz. Once we have that, this is another example of how we can pre-compute a bunch of convenient unit conversions. You also have delta samples. So in other words, this counts how many samples we are to generate this frame. And so all you do to do sample generation is you do basically this. Mu delta samples. And let's say it's stereo generate sample. And this is where the trick is. So the beginning of this temporary sample buffer is always this fixed size array. But as you're doing this sort of increment as you're generating samples in a given frame, you basically know how many samples you generated, because that's exactly as far into the buffer that this samples pointer points. So when mu update does the push to the audio API, it basically does the copy, and if necessary, maybe it does a sample rate conversion if absolutely necessary. Whatever it needs to do, it does it at update time, and it essentially knows that filled in samples are in range from mu sample buffer to mu samples. And in particular, if for whatever reason you don't fill in enough of the sample buffer, it can fill the, it basically knows where the read cursor is of the underlying sound playback. So it can always basically zero fill if necessary because it knows how much you filled in. So in this case, if you literally never touch samples at all, it will just fill in zeros and it won't actually play anything. So that's like another, I mean, like I think it's like a neat little way of doing it. That's sort of like absolutely minimum ceremony in order to generate samples and track how many samples need to be copied and whatnot. All right. Wouldn't you want audio always on separate loop? What do you mean by that? Separate loop. Do you just mean like in a separate thread? Um, you can certainly do various. I mean, you can generate audio. You don't have to do it every frame if you don't want to. Um, Depending on how your whole API is designed for audio, uh, yeah, like another thread. I mean, I don't think that's necessarily true. It may be, but even if it is, you still need to. You can totally do it in a different thread, but I think even so, you still need to somehow synchronize so that yeah. I actually intentionally wanted to. Yeah, I guess that's a good point. I'm kind of thinking mostly single threaded for this. Um, I'll have to think about how this would work differently if I wanted to do it off thread. But honestly, most of the time, so the main thing I want to use this library for is like not like completely industrial strength applications. I want to use it for things that are like mini project scale, right? Like that does all the stuff I want, but it doesn't necessarily, it's not necessarily maximally multi-threaded or something like that. So I value convenience a little bit more highly for this kind of stuff than I would if I was writing like a full game, perhaps. And I think this actually goes back to another thing, which is the whole notion of only sampling at the update rate and potentially missing key events and stuff like that. Is also an issue with this API style, right? Like you could certainly address it by, for example, rather than having update, if you do manual push pulls, you could do something like, you know, while pull, and then do some processing in here. Like you could surround your whole main loop in this kind of thing, so that it will never miss events, but still have the same overall data layout. And then only do a push once there's no more things to pull queued up. But like I kind of like this style, and I think it works well for the kinds of applications I'm interested in using it for. So yeah, um, what's another? What are some other data structures we need? I think like another interesting notion is something like an analog button, like the right triggers on a 360 gamepad or something. And for an analog button, you both have a value. Mouse scrolling. Yeah, I'm going to do mouse stuff as well. Um, for something like an analog button, you both have an analog value. And let's say it's 0 to 1. You also have an interpretation of an analog button as a digital button. So you also have this. Maybe I should put it beneath it. And the way it translates is that there's a threshold, which is also part of the button. And you can change this at any time, by the way, because it's not like hard-coded. And then to process an analog button, you basically update the value to whatever the new float value is. You compare, you translate this into a discrete Boolean based on the thresholding, and then you do the normal digital button state management in terms of, this basically would be value is less than threshold, and this would be the same kind of edge trigger logic. So yeah, so you could do this. And now if I want to do a gamepad, I would do something like this. Let me just look at my 360 controller to see what buttons there are so I don't forget. But there would be, I guess there would be some digital buttons, like X button, Y button, an A button, and B button. And there would be, well, let's see, I guess we have some analog buttons, which are left trigger, right trigger, and left bumper button, and right bumper button. And then we have some thumbsticks which I guess would be axes. So this would be like left thumbstick or just left stick. This would be right stick. And then we have some D buttons for up button. These are just D-pad. Something like this. I guess there's also a left thumb. So this is left thumbstick, right thumbstick. There's also left thumb button and right thumb button. Yeah, so does that make, I think that's right. I guess for a mu axis, well, I guess it wouldn't be an axis, it would be several axes. So maybe what we need is, what do we call this? A stick? So there would be an x-axis and a y-axis, and there would be a value which goes from -1 to +1, and I guess there would also be a threshold, dead zone threshold, something like this. Digital button. Let's see. All right. The data API approach. Yeah. Okay, maybe it is in the air. Like, I actually think this API style is like so much better from, like, okay, so the thing I really like about this is just when you write the code for actually using it, like, it's so much nicer. Like, for example, look at this. If mu gamepad x button released, do some stuff. Like, how nice is this line of code? Not to, I guess, flatter myself, but like look at this code. Like this is exactly what you want to write, and it's all right there for you. The names are short, they're readable. You don't have to call a bunch of functions. It's just right there for you to use. Like that's what an API should do for you, honestly. Let's see. Wouldn't you do? Less code, increased clarity. I'm not sure I understand what you're saying, Mark. So with the mu digital button, decal style make for less. I don't understand. Less code, increased simplicity. I guess I'm not sure what you're saying that in response to. Anyway, I guess we'll want this too for in a sec. Oh, right, we haven't done mouse yet. So is that it for? I guess there's also select buttons. If you're looking at a 360 pad. What else? I'm looking around on my controller just to make sure I didn't miss anything. I think that's it for a gamepad. Instead of repeating type A, type B, just oh. Maybe I basically never repeat. I never do multiple type like variable declarations on one line. Almost never, and certainly not for structs. But that's just my personal habit. But I do try to organize them in clusters so they kind of look like they're grouped. But yeah, so I think I'm okay with this. Okay, mouse. So mouse. So what does the mouse have? It has a couple of digital buttons. So it has a left button, I guess potentially a middle button. Actually, let's forget about the middle button because I'm not trying to handle. I guess there's also like weird gamer mice with side buttons. I actually don't know how they show up in the Windows APIs, but let's just say left button, right button, and then there's also a position. And I think, well, I guess this shouldn't actually be floats. Although this is maybe a good example of how you can do multiple things. So you can do both screen position, maybe position is a window relative, and then you also have a screen position, which is obviously screen relative, as the name suggests, but scroll wheel, what was the other thing? Middle button scroll wheel. Yeah, I guess that's true for the middle button scroll wheel. Actually, god damn it. I can't even remember how scroll wheels are surfaced in the API. They're just discrete events, right? Let's see. The distance. Yeah, okay. So I guess this would be a an int, which is like wheel. The other thing I guess I want is position delta. I want both the delta potentially and the absolute position. Let's see. Let me just think for a sec. Mouse delta position. And for the wheel, I think there's both a delta. Let's call it position delta. Is probably a better way to group things name-wise. So this is position, yeah, position delta. And then there's a wheel, which I guess we can keep an absolute value. I don't know how useful that is, but we can certainly keep a wheel delta, which is relative. So I guess it will use these units here. Face buttons on the PS3 controller analog. So I'm going to be using X input, and so don't really care about any other controller, honestly. And even for other controllers, the thing you can do is what SDL does, which is basically you have a mapping from some other controller to X input style state, and then that may lose your information, but yeah, I'm not really trying to support everything. Yeah, well, infinite in terms of current position. My idea here is that even if it's infinite, if you want to sample it, for example, at two events, like basically the way you should think about the wheel variable, the way I'm envisioning it, is it starts at 0 and then it can go up and down. And so there's no real natural origin. The origin of the coordinate system is just wherever it was when the application started. But by storing it like this, it does mean that if like let me give you an example, and this is contrived, right? But suppose I have if mu mouse left button pressed, start wheel equals mu mouse wheel, and if mu button mouse, let's see, right button pressed, I can do something like this. And the point is, we're sampling the start value and the end value, and we can just subtract them, and they will give us the delta. And so we don't have to accumulate the delta ourselves. So it's just really a convenient way of sampling at 2 points and then comparing them after the fact. Does that make sense? So it's not that the coordinate system is inherently meaningful. And by the way, this works because of signed wraparound, which I guess is not technically legal C. So maybe, well, I guess if I cared about the C standard, I would care, but maybe I should start caring since Visual Studio is apparently adding optimizations based on undefined behavior for integer overflow. But that's sort of a nice thing you can do under the covers so that someone doesn't have to manually track the delta and accumulate them over time to get the final offset between the initial and final state. All right. So yeah, I think this is probably what I want. And again, like just to go back to it, I think this notion of having redundant representations of the same state is extremely valuable. If you guys go and watch Casey's old API design talk, he goes over this. It's something that's actually frowned upon, generally speaking, where the idea of minimality and orthogonality is sort of highly prized, and I think often for good reason. But from an end user's point of view, having kind of the data right at your fingertips that you need without having to ask for it very kind of carefully and explicitly is a huge boon. Now, the downside is you're adding more surface area to the API. So if you compare what I'm doing to something much more minimal, there's probably 3 times as many fields you would have to know about. On the other hand, as the designer of the API, I'm making the judgment that you're going to care about a lot of these over time. And so you probably should want to really know what they mean so you can use them. Add input character. By the way, you can totally translate this into something like Dear I'm GUI's input character, because I can always do this. Like if I was using, let's see here, if I was doing something like add input character. So the way you should think about this is that this thing called down essentially means X input event happened. So if you're using, I can't remember exactly. If I wanted to do this, I can totally do this. And if I wanted, I could do a loop over all of these. Right? Now doing the loop is sort of, it's 256 iterations per frame. Honestly, no one cares. So this totally works. And the other thing to keep in mind is that because of the granularity of this push-pull model, you can get you can get several key events in one frame, and so you won't necessarily just get one hit as you're doing this iteration. But anyway, you can do this kind of translation even though the API is optimized for kind of the random access style of state checks. But you can do that if you want. Let's see what people are saying. All right. Is there other stuff? I haven't even started writing code that actually implements this, but I think maybe the idea is more important than the implementation. So I do want to kind of go over it before we dive in and write a bunch of code. Let's see. Why it's called Mu? It's called Mu because it's media utility, and also because it's a pronounceable short thing that you can put as a prefix in front of things and is unlikely to collide with other things. But you can also say it's mu because mu is the Greek letter that's used to signify micro, and it's intended to be a small minimalistic library. So, I mean, I guess there's a bunch of explanations I just made up on the spot. All right. What else would be useful? I guess we haven't talked about graphics yet. I think graphics is a little bit different because you're probably going to use GL or D3D, and so the main thing you really want the platform layer to do for you is something like DXGI or Wiggle WGL in order to just do the swap buffers that's more tightly coupled to the underlying window handle, but you don't really, well, you don't want it to do a lot of stuff for you there. Oh, no friction. That's another good point, Sam. I hadn't thought of that. Although mu would maybe stand for friction, right? Like that's the frictional coefficient. I guess it doesn't imply whether it's big or large. Yeah. I guess these are also events. Okay, let's see. Was there anything else I wanted to talk about before we jump in? Text, time. I guess we also want absolute time. So time in nanoseconds, time in microseconds, time in milliseconds, and maybe this is a sin. I'm going to say time in seconds, but it's going to be a double. So that's, that's not too bad. Maybe I should just leave it out, but it is sometimes useful to just have a time in seconds, even though I know in general you have to be careful about using time. But actually, the main issue with using floats for absolute time, the way some people do, is that they don't just store the final result as a floating point number. They basically do all the accumulation in floating point as well, and so you don't just get the quantization at the end, you get it every single frame, and so you get build up. If you do it this way, it's actually pretty fine, right? Like 2 to the 53 seconds precision, because you're always going to regenerate it every frame from whatever the primitive unit of time measurement is. So anyway, let's see here. Okay, gamepad, keys, quit. I guess there's maybe other messages. Maybe another yeah, there's something about how you handle window resizing we should probably talk about, but I think this is enough to sort of start maybe coding some shit. And I should say this is all stored in UTF-8, of course. Even though it's Windows, we're going to do the conversions only at the boundaries to the API if we need to use the UTF-16 APIs in Windows. All right. I think that's enough so we can start writing some actual code. Oh, did I really write UTF-16? That's pretty funny. Or UTF-8. Mu max samples. So I don't know how big you want to make this. You want to make it several seconds for the worst case, I suppose. Let's just make it some big round number, like 1,000,000. That's pretty big, but don't care. Let's see here. Does that make sense? I think so. Screen position. Position delta. Wheel delta. Alright. Alright. I guess let's get going then. Input samples? No, it's sound samples. Samples is sound samples. I could probably clarify that. So, incidentally, there's also, I guess, some other stuff I want to show once we get going with this. I had this code I wrote as a test a while back, where the impetus for writing this code was to figure out how to do a true non-callback Windows message loop. Now, the problem is, even though Windows has, on the surface, this really great API with well, I don't know how great it is, but it has this sort of peak message API where you can pull for messages, and dispatch message does in some sense do a callback, but even but in theory we're in the midst of the message handling. We're not just being called back when they feel like it. We're the ones popping messages and dispatching them and stuff. The problem you run into is that there are certain modal there are certain things in Windows that trigger recursive modal message loops. So, for example, if you start, so I'm going to take the Chrome window and I'm going to left click drag. So now I'm doing this. As long as I am actually holding down the button, and the same is especially true, I guess, which is the case I ran into it originally. The same is also true if you're doing resizing. As long as you are actively holding down the button and performing this action, um, the message loop is recursive. So relative to the code we were just looking at here, when I start dragging the window, the initial enter window thing actually, I think, gets handled at our loop, and we do a dispatch message, and it has this WM enter size move event. And once this happens, the default WinProc, I guess not even the default WinProc, just the way the overall thing works, will recursively enter a message loop where it will call your window proc, but it will never return to the top level where you called into this dispatch message until you release the button, and then this exit size move message is sent. So the problem with that is basically your main loop won't get a chance to run. So there's a few ways you can handle that. But none of them are really great, the traditional way of doing it, because they require you to have a callback API for the inner loop of your game, which is, I don't think that's certainly not in a supposedly platform independent abstraction layer. I just don't like callbacks. There's some platforms where that is encouraged, but I just don't like that style. I like to be in control of the message loop. So the question was essentially, how do you create an interface, an API that still looks the way you'd hope, right? Where every time I basically process a message, it's going to return to me in a reasonable amount of time. Now, it's hard to define what reasonable means, but certainly finite. It shouldn't be unbounded the way it is when I do this. And so I tried a few different things for that. Finally, I got a suggestion from Richard Midden about just using fibers, and that worked great. So the idea here is you have a fiber, and the fiber is the only place where the window proc ever gets called. And so you have this fiber message fiber proc whose sole job is to essentially process messages, and every time it's processed a message, it will switch back to the main fiber, which in Mu that would be like the game thread, the main game thread. Now, by itself, this isn't enough. You also have to do a switch at other times in order to get the main loop a chance to run. And we do that using timers, where basically anytime we're entering the modal loop, we set a timer, and I think right now, I guess set timer, this is in milliseconds, so this would be every millisecond, which is maybe a little aggressive, but okay. As long as we're inside this modal loop, there will be a timer that fires every millisecond, or the aim is to fire every millisecond. And then inside that timer, and also when we get WM Paint, we will actually switch back to the main loop. And so this way, the main loop will not be starved basically by these modal recursive message loops. Okay. Oh, so you're Jason Wilkins, I guess. I actually didn't see these comments until I just pulled up the gist in preparation for the stream. But yeah, so my goal is basically we're going to do something like this. We're going to use this sort of fiber thing. It'll be completely under the covers, right? Like the Mu API won't expose it. It'll just be an implementation detail. But I think probably this is not as well known as it should be. I think most people just capitulate and use callbacks. But using fibers is sort of a way of getting a lot of the effect of callbacks without actually using callbacks from the API side. So anyway, we're going to do that. Okay. So let's see if I remember stupid Win32 shit. Right, so so we're doing, let's see. Okay, so we basically have to register native specific junk. I guess another thing we'll need to mention is that in this struct we will also, oh, actually, before I start writing the loop, let me mention another, yeah, sure, let me post that here. Okay, I wanted to mention another thing about some of the API design here. One thing I realized is that, and the one thing that throws a wrench in this theory is sort of the native junk that's about to be added here. But if you consider all of this, can you imagine, like, so this basically represents the state of the application as far as the Mu library is concerned at the last time you did a push-pull, right? And so what you could do is you can actually serialize this struct and replay it. And the one thing that becomes difficult about that is there's some hidden state related to native handles and stuff. For example, there's a window handle under the covers, and there's some sound device stuff and whatnot. But you can imagine that there's a way to sort of reinitialize the native junk from any given struct you pass in. And so one of the things I want to try to do is I wonder if you can literally just log these every frame and potentially do some kind of playback of not the actual game logic, but just the output of the game logic. Because essentially everything here, and this doesn't work with things like D3D, right? Because they have their own separate set of things that are being dispatched. But for the stuff here, in theory, you would have a fairly complete picture that you could use to replay things. So anyway, that was another thing that I thought would be interesting to explore at some point. Awfully familiar. What parts of this looks familiar? I don't recall Casey using this stuff. Does Casey use fibers? Or do you mean the Mu stuff? I don't recall Casey's platform layer looking like this, but maybe I should go and take another look then. I'm curious what parts you're referring to. Anyway, all right, let's start doing the window class crap. So window class. Let's see if I remember all that has to be filled in. So there's a window proc, which, let's see, all result. That will be static. Okay, wrong order. I guess we can start with just having that do default window proc. yeah, I guess maybe I don't recall Casey's platform layer in detail. I definitely think the massive struct is not that uncommon, but maybe yeah, maybe the thing that's less commonly used is that rather than having sort of event queues, you just sort of push stuff, you push the current state into it like that. So yeah, anyway, um, okay, I guess let's just start coding. What is going on? Or is it callback? Why is this thing anachronism? Oh, okay, there you go. Allegro library. I vaguely remember Allegro. That was pretty fucking awful, though. That was one of those bloated uh, libraries from back in the day. Let's see, what do we need to fill in? Actually, I guess we don't really need to make it a W if we're just filling in that thing. Last name and then style. I think those are probably the only two we need. That was it, register class A. What does that return? Oh, that returns an atom. Okay. Okay, maybe this actually, so another thing that would be nice to do. Um, okay. And then next we have to create window, right? Actually, I guess let's do some. What was that? I think we just want to get that in there. I think so. I'm just thinking about Unicode conversion. Maybe because it's UTF-8, I just get lazy about it for now and don't do it until later because I don't want to use the. All right, let's just create a window. So class name is mu, style is good. What are those called? WS something. Overlap window. Style. Oh. Okay, so that's a good example of how to do some fun. X, Y, see, use default. Well, let's see. Those are ints, right? Yeah, those are ints. So window X, window Y, window width, windows height. If mu I guess the clearer case of that are like size X. So if this is non-zero, we get it. Otherwise, this is CV use default. Okay, let's see if that does anything. Oh, is it just because it's like a monster struct? Yeah, that's probably why you don't want to do that. It's also not the intention that you make it a global variable. For one thing, by making it a global struct, the fact that it's zero initialized is nice. You don't have to write this, and it also means it doesn't take. I mean, it doesn't take storage in the executable because it's in BSS or whatever it's called. Okay, so that worked. Okay, that actually showed a window. Oh, yeah, sorry about that. I mean, frankly, back when Allegro was on my radar, I wasn't enough of a programmer to complain about anything. But I just remember. Well, let's go look at it. Actually, I don't know if these are probably like the modern Allegro docs. But the thing I remember about Allegro is that it was sort of like it was sort of a all over the place kind of API, kitchen sink API, and it didn't do enough, and it did both too much and too little, I guess. Like usually, what I wanted back then was something that would just help me put stuff on screen or play some sound, but not provide like a sound mixer or a music system, or whatever. I recall Allegro had a bunch of sort of mid-level features like that are kind of just awkward to deal with if you're writing your own thing. Anyway, all right. One thing that's a little awkward, by the way, by using 0 as a default value is that, you know, I'm actually just going to say that 0 means default, even though that's totally not. I mean, it's a perfectly valid value. It's not an out-of-band value or anything. I guess we're not using that. Once we've created the window, we have to actually go back, get window, what is it, get window rect. I'm trying to remember what the arguments are. MSDN, get window rect. I get client direct is actually what I want for this, I think. Although that means I have to do adjust window rect. Like basically, the stuff I care about is not the actual window size. If I'm like a media app, what I care about is actually the client area. So I think is it adjust window rect? What is it called? Calculates the required. Okay, yeah, so you see if I remember what the, anyway, we were going to fill this in. We're going to do window rectangle. Okay, yeah, left top, right bottom. Oh, I guess this is the stupid Windows coordinate system stuff. It goes in the wrong direction from how normal things work. So, yeah, and then we have to say overlap window and menu. Let's not take one argument, okay. So let's just see, what if we say this has to be 100 wide by 200? Oh. All right. By the way, for people asking about VR stuff, I'm very careful to not talk about anything work related. So even though my day job is VR, I'm probably going to say as far from that as possible, just for legal reasons. So I hope people understand that. Yeah. Oops. That's not what I wanted to do. after this fact, we're going to have, let's see. I see, so this, wait. I guess this is like the opposite of what I want. Calculate. No, this is what I want. Oh, I see. So left to right is exactly that, and then this is, okay. Yeah, that does look correct. So the adjusted window width is going to be right, left. This is 116, this is 100 and... Okay. This is return. I don't know why this can fail, but let's just say it does. Let's just keep whatever they passed in. Get apply direct. It's a little annoying that you get all these, I don't even know what library is this. Is this ATL? Oh, it's MFC, Jesus Christ. Yeah. Okay, let's see here. Is it get client rect? And then, actually, let's just set a break. Let's just walk to here. Cannot convert. Oh. No, I haven't stepped over it. So right minus left, and bottom minus top. Oh, it should be, yeah, it should be bottom minus top. Okay. Oh my god, did I close that? Okay, so now mu should have name and position at 0. Is that right? Oh, it's relative to the corner. So I also need the window. I don't remember what window placement is. Oh, that's something else. Yeah, window rect. Um, okay. Position 255. That seems reasonable. Then actually I should have update window state, or update window, or actually let's call it pull, because that's what I call it. Pull window state. Um, 75, 75, probably reasonable, and this seems like a reasonable size. So then if I go back and uncomment this, I should actually get the actual thing. Oh, that seems definitely wrong. Let's see what's going on there. So this is use default. So these are all use default. Oh, I guess I can't do that, can I? How do I do that before? Actually, I guess let's put it this way. we only do this if you're not specifying defaults. So if they're both explicit, then we do that. Clearly, that must have been what was going on there. Yeah, that looks right. So that's like a fairly sizable window now. Okay. I think I'm going to put all this stuff before here, so that this section here is really the only section that's doing anything related to the window creation. Okay. Let's see if... okay. I guess for now, let's do explicit push-pull, and then we can join them together in a single function later. So that doesn't exist right now. Okay, so we have a window, but of course it's not really being served, but we have a window. For the pull, we do a pull window state. So actually already we can do some basic stuff. Okay, so let's look at the output. Actually, we're not pumping the message loop, so we're not even going to be able to move it. And now, oh, I don't know, sorry. I don't know if you guys, well, I'm sure you guys have run into this, but like if you back up the debug output window with text, Visual Studio does not approve. Why do I pass mu around when it's already a global variable? It's not a global variable. It's only a global variable in the example code. So I'm just writing everything in one file, but I'll eventually refactor this. All right. I guess I'll appease the... Okay. Maybe I'll do it a little bit differently by... I don't know. Actually, better than this. Let's do the actual message loop, I guess. If mu not, oh, yeah, thanks, that's a good catch. All right. what was I going to do? Okay, so let's go back and look to remind me what some of the. All right, let's just do the basic for now. So we're going to do if peak message. What are the arguments? All right. If there's a message, then yeah, we do the translate and the dispatch. And we can do all of them for now. Once we refactor into fibers, this won't work. But now we should at least be able to move the window around, even though it's not redrawing correctly, because it's using the default WinProc. Although I still have a garbage argument. Just make sure this is getting called. Okay, so this is getting called. Okay, I was using Unicode rather than ASCII. So that's working. But yeah, let's try to do the thing we were doing before, I guess, just to show that the pull window state thing does something reasonable. So if we move this around, incidentally, this is a really. Did you remember you guys who were here earlier when I was talking about why I want to use fibers? You can actually see the problem right here. Note when I hold down, so I'm going to start. I don't know if you guys can hear my mouse, but I'll now left click on the window and start dragging and not let go. Can you guys notice the debug window isn't updating anymore? It's because it's inside a recursive message loop, and it's actually never going to return until I let go, which is why you're not seeing updated X, Y, and Z coordinates. So this is actually like a really good test case to make sure that we're properly yielding to the main loop. And now it's going to go back, yeah. So that's garbage. Same thing happens with resizing. It's all like a modal recursive message loop. Same thing also happens, I believe, with this. So when you're inside this sys menu, it also stops yielding, and that also is garbage. So anyway, yeah. So I guess we'll tackle that next. So the main way we're gonna do that is we're gonna have a message fiber proc, and yeah, it's basically. So I'm not gonna do all this sort of good citizen, not hogging the CPU stuff. I'm just going to do the obvious thing, which means we're going to do basically this. We're going to do a single, well, switch to fiber. What's the argument here? So we're going to create a fiber, and so we have to put that in the struct. Actually, I'm just gonna put all this in a separate struct. Okay. So we created the window. Okay, before we do that, let's create the, switch thread to fiber. What's it called? Convert thread to fiber. 0, no, mu, and think it is 0 for this one. And so that's going to be the main fiber. And then for the other one, we are going to create it. Mu message fiber proc. And we're going to pass in this thing here. Didn't I call it that? Okay. So now we have these created. They return handles, right? Oh, it's an address. How about create fiber? Are they all addresses? Yeah, okay. So these should be void stars. Okay. Let's just make sure it doesn't crash. Yep. Yeah, the timeout stuff, I'm actually not sure about the best way to do it. It was just an example of how to do some kind of back off, but yeah. All right. So let's get the message loop going here. Is it yield to fiber or switch to fiber? Main mu132 main fiber. So for now, if we do this, it actually should just keep working. It shouldn't be any different, basically. Like the control flow is going to be identical. Well, if we wanted to make it perfectly identical, we would do it like this. So let's maybe try that. And so if it should still respond to, okay, it's not. So it's not working right now. Oh, I know why. It's because I should do switch to fiber 132 fiber proc. Okay, that didn't work. Well, I guess we'll find out why. Okay, that just sort of didn't work. Did that not get created? So we have a main fiber. Oh, I have to have a infinite loop in the fiber. It will never return. So let me see if, I'm trying to remember if fibers have return values. Yeah, they don't. But they do need to be my callback. Okay, so that should work. So now so now we can still process the default window proc through the fiber, and it's essentially just ping-ponging back and forth between the main and the message fiber. So this is identical to the code before. It doesn't actually do anything for us now, but at least the message pumping is now happening in a separate loop. So the next step would be to enter size move WM exit size move. So we're going to okay. Don't have to be window specific. And then an ID and an elapsed time and a timer func. And we don't need any of those because we're going to be handling it with messages. And then kill timer, I think, is just the ID. Yep. So that should work. No, it does not. Probably also needs a window handle, right? Yeah. And that's optional. Okay. And then we have a timer. And the timer is just essentially going to yield back to the main loop. Okay, we don't have user data, which we will need. I'm trying to remember how you get user data into a window proc. I guess you can use like pass user data to WinProc. I think you get, is it get window long or something? Yeah. Okay, so once we create the window, set window long putter. Passing the window, the index, and the value is going to be mu. Does that work? Okay. And then we're going to get this from get window long putter window. Something like this. Oh, it returns it. Okay. Cannot convert from long to, okay, so we have to do a cast. Is that return size actually big enough? I wonder. Isn't long 32 bits? Maybe I'm wrong about that. Probably. You know, that is 4. What the fuck? I have to go to the bathroom. Just be right back. right, I'm back. Regarding VSync, I mean, VSync is great, but it doesn't always. I mean, like for example, I guess on older Windows versions, you don't even necessarily have an ability to get VSync for. Well, I guess you can use VSync as a timer, but not actually have your present be synchronized to VSync. But yeah. All right. Let's see why this thing. Oh, I see. It's because I'm actually compiling on 64, so that's fine. Okay. Guess it's user data with an extra underscore, maybe. What the heck? It says it's right here. Oh. Okay, I see. This is some fancy, some stuff I don't recall dealing with before, but it's been a while since I did a lot of Win32 stuff. Can I convert? Oh. Okay. So, if I now do Win32 main fiber, that should just work. Although we will see, won't we? So, okay, so right now you can see this is spamming, spamming, spamming. Yeah, no, it's still not doing what I want. Well, it's also off the screen. Yeah, so right now it's not yielding, and if I let go, it'll start yielding. Okay, so I probably... Oh, I also... Oh, I know why. Let's do it like that. Okay. No, that's still not doing it. Probably I'm not using the right set timer arguments. 0, 1. Okay, it does. Maybe I do have to specify the window. This is some breakpoints. Okay, so that is executing. Should probably take the return value. Anyway, let's... Okay, so that is actually executing now. If I step through that... Well, I guess I can't step through with a debugger. It's a little awkward. Let's set a breakpoint. Oh, actually... So it should return from this point. What's a stupid thing I can put here to have a place I can breakpoint? Okay, so right now there's no timer, and then I do this, and then I'm going to set a breakpoint here and do F5. Well, I don't really know whether that came from the normal return because I released the mouse button or not. Oh, maybe this thing's actually not filled incorrectly. I guess that would be a good test. Okay. No, that is filled in. Hmm. Oh, the timer ID isn't allowed, but for some reason. What's the first argument? Okay, maybe I should use this. Okay, let's try that. Well, actually, the timer was firing, so that can't be it. Oops. Okay. That's very interesting. I guess maybe because of... No, it doesn't make sense. Actually, let's just try something. Okay, so this is... I see. So this is actually... Okay, so this is actually working. Yeah. And if we move... Okay, so it's not updating the window position. That must be unrelated. Oh, it was just... That's strange. Oh, I think it's just because it's so backlogged with messages. Oh god, fucking debug window. Okay, clearly we need another mechanism. Okay. Last print text. If get to count minus last print text is greater than 250, we do this. So this should only print 4 times a second. Okay, so this does work. All right. I think what I was seeing was we were so backed up with debug messages that I was confused about, like, basically it wasn't the lack of responsiveness in the actual message loop. It was just the debug window was so heavily backlogged that I was looking like deep into the past or something like that. Okay, so that all seems to work now. Okay, so we want to do the same thing for enter menu loop. And the menu loop is the sys menu. So we should, well, actually, let's do it before and after to make sure I'm actually telling the truth, I guess. So right now you can see things are actually printing. Let's make this smaller so we can see shit. Things are printing. And now if, let's just tail the window. If I press the sys menu, open the sys menu, yeah, so you can see it's halted. And if I close it, it resumes. And so if I do this, we should no longer have that bullshit. So now if I open the sys menu, it keeps on trucking, which is what we want. Great. All right. I think we can, yeah, we can still have this. I think what we want is this, because that way it's up to date as of the message processing. Yeah. So that's proper, nice and proper. Let's do 10 times a second. I thought I saw some hiccups. No, it's probably fine. Anyway, so that's actually, I think, all we need for fiber-based decoupled message loops. Let me go and look. Oh god, did I close my gist? I guess we don't really need it anymore. Although I did post it here, so I can just dig it back up. Alright. We're not going to do this wait stuff, although it's nice to know you can do that. Is there anything else I'm not doing? Alright, well that looks like what I wanted to do. Okay, so let's do some other messages, I suppose. So wm destroy, we're essentially just going to set this to true. And actually, let me show you what happens if this is not done. Even if I close the window, the application is still running. Can you see that? It's both here and I have to close it manually. So and actually it's not that kind of true. It's this kind of true. So now that works. And I can do it with F4 as well. Yep. Or not Alt F4. Okay. Boom, 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 boom. I think that's it for the basics. I guess the next step is to do input, and well, maybe we can do time. So these are all set and maintained, as is this. We're going to do input in a bit. I think let's do time. Let's do time. So for that, we will do pull time state. The thing we have to do at init time, though, is query performance frequency. Time, I guess we can say timer frequency. we should probably, aside from these more like natural SI units and whatnot, we should probably also have one that's just raw, if you're so inclined to use those. Delta. I guess we can call them ticks. And then we can have ticks per second, which is the frequency. Maybe we'll put these sort of a little out of the way to suggest that they're a little lower level and probably not what you want most of the time. And then query perf. Okay, so this would be ticks per second. Large integer. Probably want to have something like start initial. Start text. Maybe we will put these up here, and then this stuff down here will be kind of metadata-ish. Okay. So time and ticks should be 0. Well, I guess we'll actually, so this should be start ticks should be whatever the current performance counter is. Large integer assigned. I guess that's true. That's kind of awkward, given that those values can never be negative. So this should do the conversion. Okay, and now when we do pull time state, we should get some stuff here. You might want to run the timer always, as always, when Windows jump into modal loops. Don't run with messages. Interesting question. Do you mean like child Windows? Because it already has, I mean, the stuff I'm using it for is already for the modal loops. I don't think I'm going to need any. I mean, like, I'm not really exposing a full window system where I need child windows or something. So I think this is probably okay, but it's an interesting point. All right, so this is current text. And then if we update time and ticks to current ticks, and I guess I should also have one that says like initial ticks. There should be one that's like current ticks. Well, I guess that's time ticks. Yeah. So current ticks is that. Delta ticks is current ticks minus u time ticks, and then time ticks is equal to current ticks, and then we have to do all the conversions. Well, let's just I guess do a print of this. So this would be delta ticks and time ticks. Delta is constant, so they're all constant. This looks like complete garbage. Oh, it's because I'm not calling that function. Pull time state mu. And in fact, I think, yeah, the way this should be in general is like that. Some of these deltas are really small. I guess that makes sense if it's just a busy loop and there's no window dispatch stuff. So okay, this time text is monotone, the other one sort of in the ballpark, so we're going to say that's probably okay. Actually, I'm just going to call them pull time because the state part is sort of implied. Alright, pull time, so this looks reasonable. Let's do the unit conversions. I'm just going to copy and paste this so I know what I have to fill in. So delta nanoseconds is current ticks, well, delta ticks. Delta ticks divided by ticks per second. Right, so this would be initially seconds, milliseconds, microseconds, nanoseconds, and then microseconds is and then delta seconds would be, we just do the whole thing in floats. seconds. Or time and ticks. Well, I already have that initialized. Actually, this isn't right. Current ticks. This should be current ticks minus initial ticks. That's how we do it. So 0 is when the program is initialized. And then from that, we do the other stuff the same basic way. For time and seconds, time and ticks per second. Okay, so what do we do with time seconds? Delta samples. Just gonna get to that later when we get to sound. Seconds. That's right. All right. This looks, I think, in the ballpark. So let's do some tests here. And actually, let me just bring over my standard printf garbage. This would be a list. Yep. And we're just going to do that like this. All right, and then we actually have to do an output debug string A. Okay, so that still works. And actually, now we can actually use our time functions to drive this. So we can even use floats without feeling too dirty. Last print time is 0. And then we say if mu times seconds last print time. If it's been more than 0.1 seconds, then we print an update. Let's see if that works. Let's start with 1 second just so we can kind of eyeball it, whether the interval is reasonable. Possible loss. Okay, I guess because this is the absolute time, we have to do that. 1. 2, 3. Okay, that seems reasonable. Let's do 10 times a second. Okay. Nanoseconds, microseconds, milliseconds. Is that right? Yeah. It's like, certainly the ratio between these is like, grows by a factor of 1,000. So that part of it looks good. Let's just shortcut these. I guess that's kind of what you expect. Well, so let's say this is, oh, it's delta. So this would be like ds, I suppose. That's off in the weeds. I mean, all these numbers are off in fucking La La Land. Except for the absolute numbers. Oh. So delta text is current text minus time text. Oh, dope. Oh, that is right for that. Why is this not? So it should be ticking, so milliseconds should be like, DMS should be around 100. And it's like, Jesus Christ. Regarding starving the main loop, I mean, it's actually pretty severe, right? Like, think about network sockets that will disconnect because of keep alives. Like, of course, you can sort of blame the user, but the idea that you're starving, for example, a network socket for keep alives because someone is holding down a button is kind of complete insanity. So I think the idea that you return at regular intervals, small intervals, is a fairly basic guarantee that should be explicit or implicit in any kind of API that's looked like this. All right. So what am I doing wrong with this shit? Current text minus time text, and then, oh. It's because this is offset. No. This is already subtracted. So time takes already has it subtracted which means it's being added in, which means I have to subtract it back out. Okay, what happened to the... what is going on over here? Yeah, so DMS is on the order of like 10-ish. Occasionally there's bigger jumps, which is interesting. Those outliers are pretty interesting. Anyway, I think that's right. Okay, pull window, pull time. I guess I should start to... I think this is enough for time. I don't know why I have this. This is like C++ 14. Why I have an equals 0 in there. Or no, C++ 11 rather. Okay. Maybe I should rename some of these. Like for some of this other stuff, my convention is absolute value and then absolute value underscore delta, which I kind of like because they organize under the primary name. So maybe instead of time seconds, I should just call it seconds, which is perfectly explanatory anyway, self-explanatory. And seconds delta. Yeah, let's do that. So time underscore should just be replaced by nothing. I kind of do like delta seconds better than seconds delta, because that's how math works, right? Like the delta is in front of the quantity that is, so I think because of that I will also write it like this. Delta position. Okay. Okay. Oh, let's make sure this actually works. If I specify this, do I get... Yeah, I get a small window. Okay. All right. Okay, I think I have an idea here. If as a little thing, if you try to pull, no, I guess we can't do that. Okay, one thing that should definitely be there is there should be a flag called initialized. And then in initialize, that should be the final thing that gets set. And then in pull, if someone tries to call pull, that would be for me. Like, I don't want the API to do too many asserts just for internal error checking, although I probably end up doing some along the way. But I feel like this, oops, not the other way around. I feel like this is a pretty hard one. And maybe the way I should actually do is like okay, if, I see. Okay, here's how we do it. If it's not initialized, then print error and quit. Or report error and quit, let's say. I don't know what to call this. Print error and quit. Okay, let's just call it that. So the idea is we're going to have some sort of message box here. Okay, I guess we should test it. But for example, if I do this, we should get a, okay, so there's no error here. So if you try to run it, then it will do that. But if there's an actual error, I think we had some examples here. Like, I think if we, just as a test, if we do this, okay, well, I guess we have to try to initialize it. Okay, yeah. Okay. That's fine. All right. Do you need to do a pull inside initialize when there's another one directly after the start of the main loop? Yeah, I'm not making assumptions. So actually, let me do the next step here. Mu update does a push and then a pull. So this is a little bit of a trick, but if you do it this way, and this is in some sense the normal way, all you need are two functions to use this API. So this is sort of the golden path for the API, is that there's actually only two functions you ever need to call, and those functions are initialize and update. An update does a push to finish the current frame, and then a pull to prepare the next frame. And so you can think of this as kind of like a do-while loop where you need to make sure you do some setup to enter the first iteration, and that's what initialize does. That basically will initialize whatever state is relevant after the initialization point. So yeah. Sorry, maybe I should have made that clear earlier, but that's the intended use. But push and pull are still separately exposed. So it's if you watch Casey's talk, he talks about this, about how sometimes, even though it's frowned upon in a lot of traditional API design, having functions in the API that are not purely necessary, like update, could be done away with. You could always just do your own push and then pull. But if you're accounting for like the common case, having a convenience function, replacing two functions with one doesn't sound like a lot, but it kind of reduces the, I don't know, it's kind of neat, if nothing else. Let's put it that way. Um, I don't think I like that. That's a little too weird for me, actually. I see what you're doing, but maybe I'll think about that. For now, I feel more comfortable. Like, I don't like the idea that, I mean, first off, not a fan of, I guess, up return values for this style of API. It kind of goes a little bit against the grain of the kind of very stateful manipulating a state struct style. But also, for me, this is not really a perversion of the normal way I write a main loop, whereas what you're writing there feels a little weird. But anyway. Okay. Let's forge ahead. So I think we have time stuff working. We have basic window stuff working. Both time and window state is being pulled every loop iteration. I think the next step is a bunch of input stuff. So yeah, let's start doing input stuff. There's actually no reason to make these. There's no reason that I should make these static. Like, I'm using static sort of as a way to signify these are internal. But actually, I kind of like the idea that you can pull these more frequently if you want. Like, if for whatever reason you want to call this inside a loop to get the up-to-date values, you're welcome to do so, even if it's a little out of the norm. But these will basically always, you can call them as frequently as you want, basically. Yeah, regarding the split between core and extension, I have some extension stuff that I plan on doing later, and that's for a little more heavyweight than just one function that calls two functions. I feel like that's too much to put that in an extension library for something that simple. But the kind of stuff I'm going to put in the extension library is like image loading, image reading, writing, sound read, writing, stuff related to video read writing, like all this sort of heavyweight file format, and maybe if I have like a sound mixer or like anything along those lines, I will probably put in the extension library. In fact, I'm planning on calling it Mux, which is kind of a terrible pun, but like mu extensions. So yeah, I'm planning on having like Mux load image, Mux save image, stuff like that. But yeah, and that'll definitely be a separate extension library. Anyway. Pull time. Okay, so we should pull keyboard. Okay. Get key state. I guess one thing I did I mention indexed by scan codes? Probably. All right. Get keyboard state. What's the Yeah, I guess that is true. So maybe I just call this get keyboard state. Okay. Um, each member of the array pointed to contains status then. Okay, I think one thing I want to do is like update update digital button. Um, and let's just put that aside. But yeah, so the core, and actually let's call this pull, I guess, to be consistent. If we call this pull, then essentially we have the old down. So we can say was down. And if was down and is not down, then it was released. If not was down and is down, it was pressed. I should say otherwise it is not. Okay, so we just don't even do that. We say was down and do it like that. This would be pressed. It's not down and is down. And then hey, see you around. All right. If the higher order bit is 1, the key is down, otherwise up. If the key is in low percent, toggle is meaningless with non-toggle keys. So the higher order bit, which is bit index 7, so I guess that's another way of saying pull digital button mu keys plus key keyboard state key, and then shift it 7 places over. Is that right? By the way, I'm going to do a little bit of a trick, I think. Just so I don't have to create my own key codes, I'm going to mostly alias the virtual keys, I think. No, it's not Alt, is it menu? Something like that. Mu and then Shift. Um, and then for other stuff, you use the convention that the P key corresponds to sort of the capital key ASCII code virtual key index. So for now, I think we're just going to do something like this. All right. Okay. So far I have done, I mean, mostly basic stuff. I'm starting on input. I've done Windows. And the interesting thing about the Windows stuff is that I use fibers to have a non-starvation or non-starving Windows 32 message loop, and then I just did time with Career Performance Counter, and now I'm doing keyboard. I think what I just did was keyboard, but we'll see if it actually works. Okay, I think I'm going to temporarily disable this so we can start testing some stuff with keys. So I should be able to now say if, and we'll use a quote-unquote difficult example like control, if this is down, then control is down. That would be the absolute bare bones test. Okay, that worked. This is left control, this is right control. Okay. So that worked. Now suppose I do this. So now if I hold down, I get a press event. If I let go, I get a release event. So that was a little bit of a trick test I did here. The virtual key control maps to both the physical keys, the left control and right control, and so you have to be careful with how you handle that. So what I'll do now is I will press and hold my left control, and now it says pressed. I will press and hold my right control. Note that it doesn't change. Then I will release my left control, and it still hasn't printed anything, and now I release the right control. Okay, so that's being handled correctly. And I guess let's just Alt the same way, Alt and Shift. Well, at least Alt, because I'm never sure what the VK code is for that. Let's see here. So Alt, this is left Alt, release. This is right Alt, release. I guess let's do, actually let me, I guess, abstract it and say, keys checked. I just call them keys. Let's just do it in line again. This is left shift, release, down, release, down, release. Okay. All right, so I think keyboard input works. We haven't done text input though, and that one's a little bit interesting. Trying to remember. Let's see here. MSDM WHIR. So wparam is the character code. What about Unicode? So it's a single character, which means that UTF-8 char should, if we can do it in, we do wide char to multi-byte. Is that what it's called? So wparam is the character key. Okay. So this is well, I guess we can just call it like this, actually. Wide char to multi-byte does not take 0 arguments. Oh, so it is actually matching. Okay. So code page, we want UTF-8. Actually, for now, let's just do ASCII or ANSI code page. So let's see. Flags, I think we can use 0 for that. The wide char string is that one, and it has length 1. Okay. Let's see. Text end. So if text n plus ASCII length is less than mu text plus size of mu text buffer rather, then we can fit it in. Actually, there always has to be room for a null terminator, so it has to be less than this, -1. And We always do this. And then in pull, I think before we process messages, we need to reset text to text buffer and text and to text. No, I think that's always true, actually. Okay, so I think, no, you want to be able to have text be null to signify no data. Okay, I think that's right. And then pull, well, wmchar. Is that right? This is obviously quite a lot of work to process a single Unicode character or whatever, but I mean, fortunately, there's a limit to how fast people can type. And computers are fast, and relative to what games do, this is a joke. So I think this is probably about right. I think I probably didn't initialize all this stuff during like text should be initially 0, text end should be initially, no, actually that's not true. That's something that pull will do, so I don't have to do that. That's good. Okay. And so I think I can now write my original sample code that I wanted to get from this API, which is I do it like this, new text. You can do it like that. Most of the time it's just going to be one character, but if we artificially create a large gap, it's going to be, oh, so we're getting new text all the time, so even though it's empty. Now the debugger's hanging, which is fucking great. Sorry, just got a text message, just catching up. Okay, so text is not updated the way I thought it would be. So first, let's see if this ever gets hit. Okay, so it got hit when I pressed a character, but not before. And yet, text was not null. So in pull, I set it to 0. Oh, I see. This should be text buffer. Okay, so by default it doesn't print anything now. Now if I print D, it prints S, or P-E-R-V-O-G-N-S-E-N. Okay, so I typed really fast, and you can see it didn't miss any characters. And that's part of the one thing I'd say with this style of API is that it's really important that you don't miss characters when people are typing, much more so than this sort of like low-level key API stuff. Otherwise, you're transposing the characters or losing them entirely. So anyway, this does that job. So I think this works. Max text was 256. All right. So I think we can remove some of these comments now. We're further along. Okay. Actually, I shouldn't have to do 4 here. Because we're not using UTF-8 anymore. Cannot convert. All right. Actually, this also makes this simpler, because now I can just do textSend equals ASCII character. Okay, my name is Per Vonson. Okay, I'm just testing what you can type, sort of. All right, seems reasonable. Let's see if anyone got bored of this. Okay, there's a lot of people watching. I was going to say, this stuff is fairly menial at this point, but I will hope to get to something more interesting soon, hopefully, for you guys. So that's, what did I do? I did keys, I did text. I guess we need to do gamepad now. Maybe we should do mouse, actually. Mouse is kind of a little bit tricky. Not really, but you have to use raw input to get good data. So maybe that's interesting. And there's also some stuff here about window relative versus screen relative. Let's look at else. Anything else I missed? So keys, gamepad, mouse. I now have text. Time we have. I don't have any sound shit. Okay. I guess let's do mouse raw input. I'm trying to remember. I never remember this API. I always have to go read it. Okay. If you guys don't know about what all this stuff about HID and USIS and USITS page, this is all USB crap. Let's see, USB hid page. Yeah, this one. Usage types. So you can see in our case, usage page 1, which is generic desktop page. And right on that page, you can see ID number 2 is mouse. And so that's where, if you wanted to do other stuff with raw input, this is basically what it is. It's basically a way of getting access to lower level USB. HID stands for, I think, Human Interface Device. Human Interface Device. Yeah. So anyway, that's what this stuff is about. I guess we'll set this to our window, although I don't know if that matters or not. Okay, so in theory, we should now be getting raw input. Let's make sure. Oh, no. Probably have to call a function, don't we? Register input devices. By the way, one thing I'm not going to do is I'm not going to try to clean up partially fucked up state during initialization. So for example, if I create the window but I don't succeed in registering this raw input device, I'm actually not going to destroy the window. Now that's, in a lot of other APIs, I would consider this unacceptable to just leave things crazy, like a window on the screen that's sort of in a quasi state of dead or alive. But I don't really, with this API, if you call this function and it fails, you really have no means of recovery. So that's sort of the thinking, and I'm not going to go out of my way too much to clean things up, especially during initialization. It's another thing when things are running and there's some out of bounds condition, but during initialization, I'm just going to bail. Fail to register input device. Okay, so still working. Didn't fail apparently. Will this be multi-platform? The API is assigned to be multi-platform, but I'm not going, essentially there is essentially every platform will be a complete re-implementation. There is no great effort at splitting platform agnostic from platform specific stuff. From the user's point of view, there's one API, but in terms of the implementation, there's no partitioning. And I think that's actually the right way to do this. If you find yourself doing a lot of code that's not platform specific, then you're not writing a platform abstraction layer, you're writing something else. You're writing a higher level media layer, which is not what I'm trying to do here. I'm trying to basically do the minimum to get at the platform specific features in a convenient way. Does that make sense? So this would be possible to implement for any other platform very easily, but you would essentially just do a complete re-implementation of all these functions. So anyway, for now I'm just doing Windows. All right, so now we have to do WM shit. We want to do an unbuffered read. So this is like we do get raw input data. lparam 0 size of raw input header. So what do they want? So if this, I have to make sure I get back the size. So far so good. No algae. Okay. By the way, normally alloc without any stack checks is potentially dubious, but like this is going to be a fairly small buffer. I can in fact probably just use a static buffer, and it's also not going to have an arbitrary stack below me. This is going to be top, it's a fiber. It's basically top level. So okay. For all input header rem type mouse. Let's just do a print of some basic stuff, just like they do. Last x, last y. So those are what? X and y. Raw input data mouse. Okay. Right, so these are deltas. Now I'm clicking right left and clicking right. So we're getting raw input events for both movement and clicks. Okay, let me think about different kinds of mouse. So if you look at how we're doing mouse stuff right now, there's delta position stuff, which you want to be really low latency. And I guess you want all of it to be good. I'm just trying to think like... position should be, well, actually, let's say client area relative. I guess we can just do our own position tracking. So mu mouse delta position x. I didn't capitalize that. And then mouse left button. I will do a pull on that. Plus equals, no, but this is the delta. Oh, I guess that's right, because it's the delta across the frame. Thank you, that's a very good catch. So even though it's a delta, if we get multiple of these within an update interval, we need to apply them cumulatively. So thank you, that was a very good catch. And then for this, we do a pull. What was it, raw buttons? Mouse. I thought raw input was always absolute, but maybe not. I guess I should ensure that why does it say any combination? Like, there's no way you can end this. Okay, that's bizarre. Okay, so raw buttons. I'm assuming these are just like bit packed, right? Okay, so this is not used. Okay, so this gives the edge. I just kind of want the current state. I mean, I can certainly process these relative things just fine. It's just a little bit awkward. It's like, so then I'm like, okay, mouse, left button, down will end up being that. Uh, if it wasn't down, actually, I think I'm just going to use this still, but just infer the new state. So I will still do I'll still do left button. And then this will be left button down. It starts at this, and then if it's already down, then I don't know why would we get double events, but let's assume that can't happen. Okay, so if this happens, then the new down left button down is true. Well, if button flags left button up. Probably put this somewhere else. Okay, so this has to be like that. I have to do the equivalent for the right button. Okay, let's delete this shit. Left button. Well, actually, let's do pressed and released. Okay, that's definitely not working. Alright, delta position should also be, let's see here, pull. Let's see. So if it was previously down, Hmm. Okay, so that's released. So it's currently down. Now it's no longer down. Now, oh, I see. Um, that should work. Hmm. Oh, I guess the problem is this doesn't get updated. Um, this only gets updated when there's an event, so it stays stuck in the old state otherwise. Um, maybe the way to do that. Well, mouse delta position. Let's see. It seems like those edge flags should always be cleared at the beginning of a frame. Like, um, which basically means maybe reset isn't the right word. I guess that's actually true for all of them, but we only really have to do it explicitly for some because things like the keyboard keys always get sampled every frame. It's only the ones that are selectively handled like that which are problematic. So I guess we'll just handle them as one-offs. Okay, Visual Studio is shitting itself. Okay. So there's a press and a release. Oh, and it's still grabbing it because it doesn't respect focus. We can get to that later. Okay. I think now that I'm getting raw input messages, I have to make sure that I also defer to the default window proc. Because it's otherwise not doing the usual things that you'd expect the default window to do. No, it's still not doing that. Hmm. Create font size? That's fine. I don't know. Okay, I can do this, although it's a little bit huge here. Alright, I can try this for a while, although this feels like Playmobil to Legos, if you know what I mean. Alright. So it looks like raw input 132 war input, no longer getting mouse move, no longer getting normal mouse messages. Oh, no legacy. That's why you don't just copy code off the internet, people. Okay. Press, release, press, release, press, go, no, release. Okay. I guess we can do it with the same thing for the right mouse button. Press, release, right. Okay. Sorry, I really have to decrease the size. It's hard for me to navigate when it's like being zoomed all the way in. So that's it for these, and I guess we also have to do mouse wheel stuff. Wheel. So if this flag is set, then I guess what we do is we delta wheel is raw input data mouse, and then it has to be the same thing with the delta wheel is 0. And then after this, we have to do this, and we actually have to do the same with positions. So all this stuff we're setting around the switch to fiber is essentially prepping, like we're trying to handle as little as possible inside the actual message dispatch loop. We're mostly just sampling the current state. But for some things like raw input, I guess there's no other way to do this. So we kind of have to do this style of pre and post processing around the message loop. Does that look right? X, Y, wheel, delta wheel. Yeah. So that's left, right. I guess let's look at delta wheel to see what this thing actually does. So if mu mouse delta wheel delta and then wheel position in absolute coordinates. Okay, so when I scroll down, I get this large value, which suggests it's signed, but it's being printed as unsigned. Oh, I see why. It's because I think when I'm doing this math here, I'm not treating it as signed. Signed value. Okay, so you should actually do this, I guess. I see. So the ticks go like this. So they're in units of wheel delta. Let's see. US button, data, wheel, what is it, like 120? Where does that number come from? Okay, so that's a more reasonable unit. Okay. Precision with declined relative area. Yeah, that's true. I guess maybe I should only use. I should actually just do the normal laggy way of doing mouse stuff since it's all self-consistent. So that's probably the right thing to do. And frankly, I should probably do the mouth as well. Yeah, so okay, so let's do that. Let's remove this garbage, which gave me a bad smell in the mouth anyway. So we're going to remove all this crap. And then we're going to do this the old-fashioned way with get virtual key. So like, was it pull keys? Keyboard state VK left button. Get digital button. Left button. Oh. Should be able to do that, right? Yeah. Okay. Okay, it's being super weird with the updates. It's probably because of this reset crap. So we want to take this away. No, I guess we really do need this, otherwise we can miss stuff if the sampling rate is not there. Although I wonder if that's really it. Actually, let's go back to the Let's just go back to this stuff. We'll just do positions differently. That's fine, I think. Alright, pull. So for positions, actually, so rather than pull keys, let's have one called pull mouse. Yeah, so I'm gonna probably do exactly what you said for now. And actually, you're right. I should just, I guess, use WM mouse move or yeah, whatever. No, but anyway, yeah, I was basically going to do. I thought I could use get cursor position um, rather than processing messages, just because processing, yeah, it's probably easier to do this way. But I agree. My plan is to do exactly what you said, which is nice deltas for stuff like FPSs where you want nice low latency, but then have normal sampled position, absolute positions from other stuff. So this should give us this. If we pull the window before the mouse, then the mouse position will be up to date. So we can actually just let's just call this mouse screen position. And so we will do the updates by taking the position, I guess offsetting them like this. Does that make sense? Actually, we can just do it in place. So we do this, and then we offset them. And then we just have to okay, so I guess the reasonable thing to do here maybe would be to print the X and Y. Let's just remove this junk for now. This should be close to 0. Yep. Because this is window relative, not client relative. I thought the pull window did client relative. I guess not. No, that... what am I doing wrong here in computing? Because this is what I'm using for my offsetting in order to get plane coordinates. Um, but but you can see that I'm getting window coordinates because like up here is 0y. It should be like 0y should be here, right? Hmm. So I get the window rect, which is in screen coordinates. Then I get the client rect, which is in window coordinates. And I add them in order to compute the screen origin of that. Let's see. So window rectangle. Yeah, these always have their origins. Oh, I guess it's because the window origin is actually in the lower left corner. I probably want to invert this coordinate system anyway. I want to have um, yeah, I think it's just because of the typical Windows up and down shit. Well, I guess this shouldn't be relative to, well, let's see. So the bottom, so this, oh wait, so no, it shouldn't be that. I guess I should just find the height. Yeah. Not window points. I actually don't know that function. Oh, I see. Okay. Well, let me look at that map window points function. No, thank you. Okay, so if I do adjust window rect, um, now this should be in window coordinates, and then I should be able to actually, I guess this is correct, first of all, because this is based on a blind rectangle. Let's just call this rectangle because it changes coordinate system throughout. Now this thing is in so now it's there, and I can do map window points, I guess. And I'm doing from Win32 window to desktop. And I suppose this would be like window origin, which we initialize to be window or a rectangle X or a left and bottom, and then we want to map them to, and there's one of them, and then we go maybe like this. Okay, so the lower left corner is now 0. I guess you could make a point that this should be I see, so rectangle, go there, origin is there, so okay, so that's correct now. I guess I could just have done this actually. That would have been much less roundabout. Yeah. Screen slant. converts between screen to line coordinates, not screen to window coordinates. Oh, really? Screen to line, not screen to window. I mean, I guess that makes it easier, because I don't even need this according to what you said. When you say I don't even, for a single point, I can just use screen to client. Okay, clearly easier. I think I do recall this function. Well, I guess it would be client to screen, right? Okay. That was a little roundabout. Let's rename it to be consistent. Okay, I think all the coordinate systems are sorted out now in the way I would expect. Okay. Good stuff. Alrighty. I think that does everything related to mice. So we have the high quality deltas from raw mouse input. We have absolute positions from get cursor posts, get cursor position, and they're properly they are proper. Why is it plus minus? Oh, position of window. I see. You know what? I'm going to wrap some of this stuff up because the names are getting a little unclear. Actually, let's do it like this. All right. So I do believe that takes care of Windows stuff. So this is used for initialization, but also also updated all the time. Keys are sampled, and all the edge filtering stuff is done and maintained. Mouse is now also gotten the treatment. Where's mouse? Left button, right button, wheel, delta wheel. We've done these. We haven't done screen position. us. You know what? I'll get rid of screen position for now. Okay. We have time, we have text. I think the next step is gamepad with X input. Yeah, you're right. That's probably more self-consistent since it doesn't rely on the window stuff. I think I like that better. Or just not take one argument. Actually, let me keep it the other way. Part of it is that I'm using this to invert the coordinates. So they're top to bottom. So I think I'll just keep it like this. Let's see. Okay. Okay, let's do X input. I guess you can have multiple controllers. For now, we're just going to pretend we only have one. I realize the other thing that you want from a controller is to know whether it's connected. Okay. Okay, so we have to do a load library of, what is it? Load library X input. I'm trying to remember what the version numbers are. Boom, boom, boom. What are the, I wonder what I have. X input 1 1 1 2 1 3, I guess 1 4 9 1. Okay. Okay. So we want to make this thing a little bit tolerant so that if you don't have X input on your system, you basically just don't have the ability to use controllers. So rather than using a static loader library, we're just going to do a dynamic load library call here. Guess let's try with the first one. This returns a module. For now, eventually we're going to have to try loading a couple of different versions, but I think this is probably it to start. What's the X input get state. So that's going to be part of this. Type def. So we'll do it like this. Cannot override specifier. Oh yeah, I guess this has to be in here. Okay, like that. And then load library. Proc address. X input module. X input get state. Actually, let's just call it something consistent with my naming scheme. Cannot convert from farproc. Okay. I think we did like that. And then let's just make sure that actually loads. Okay, that loaded. And then pull mouse. We need pull gamepad. Maybe we just call it controller instead of gamepad. No, gamepad I think is slightly better. And so if we don't have one of these, then we just bail. And we call this fucker I guess I can't just call getState. There is some sort of init function, isn't there? All right. So now we have X input state. Alright. Start back, left thumb, right thumb, left shoulder. Okay, I shouldn't rename some of these to be consistent. So A, B, X, Y, those are right. Left trigger, I guess those are called left shoulder button, right shoulder button, left, oh no, shoulder button is what I call bumper button. Then there's also left thumb button, oh, those were right. Why am I confusing myself? So left trigger is an analog. These are called shoulders. Thumbstick, thumb button, select button, right, so this should be back button. Select button is like a Super Nintendo, not a not something else. All right. Okay. So we should just be able to do pull digital button, U gamepad, A button, and X input state gamepad buttons, X input gamepad, A. What's it called? Just A. Okay. So for now, I'm just going to do one button just to make sure the overall setup works, because then we should be able to just almost copy and paste it for the rest of them. So, okay, that still works. So let's do something. If mu gamepad A button pressed, A button pressed. I actually have my 360 controller connected right here, but I don't know if all the drivers are installed, so we'll find that out. Just have to untangle this thing from all the cables under my desk. Okay. Moment of truth, I guess. Okay. That works. Let me do the release one as well, just so we can get some sense of responsiveness. Okay, that works. This is the part that's a little repetitious. There's not a whole lot. I mean, we could do a macro to reduce this a little bit. And actually, yeah, let me do that. So let's say, let me do it like this. So at least we're not typing the same thing twice. I need to get all these things in front of me so I can make sure I don't forget. Okay, so A button, left trigger. Let's do left trigger last, since it's a analog. Then it's left shoulder button, left shoulder, right shoulder button, So A, B, X, Y, left shoulder, right shoulder, up, and that's the D-pad up. So up, and that's D-pad up, down, left, right, up, down, left, right. Thumbstick, 1, 2, no, there's a stick, and then these 4 buttons here. So 1, 2, 3, 4. Left thumb button, right thumb button, back button, start button. This was left thumb, right thumb, back, start. I think that's it. And then we have to do the analogs. Left trigger, right trigger. Are there any more? Alright, so we got rid of these. We have triggers. I guess we need pull analog button, which we have to write. So that would be left trigger. Current value is between, so that's left X input state gamepad. B left trigger. Okay, so what should analog pull do? Let's just get these away. Pull digital. So I think pull analog is almost the same thing, except there's a threshold involved. And this is a value. Okay, I think you set this to the new value. You set the new thing to is the value less than the button threshold. And then you do the same logic here. So that sets this, sets these two, it updates that. So I think that's what you need. So it assumes a threshold has been filled in somewhere, which I think now has to be done in initialize. So if this succeeds, I guess we can do it actually unconditionally just fine because the header is always available. So we can do gamepad left trigger threshold. See, xput trigger threshold. I'm trying to remember. There's like a macro, right? Let's just go look at the header file. So trigger threshold. Trigger threshold. I guess while we're here, we should also set the stick dead zone. So left stick, left thumbstick threshold. And I guess for these, the values are this. So we have to do like that. Is not a member. This is a stick which has an axis. I see. So we set it separately on both axes. X. Actually, let's just call it. Let's do some temp variables here. Trigger threshold. Okay. Pull analog button. So that's how we do that. For pull stick. If fapps value is less than the stick threshold. And actually for down, even though it's sort of counterintuitive, I realized I think this is the threshold, because like the biggest values means more pressed. So for stick threshold, if it's like that, then we clamp it to 0. And then we I guess pull axis would be the correct thing here. Maybe have too many data types. Maybe we should just collapse stick and axis, but I think this is somehow the right thing to do. Okay, maybe this is about what we should do. Okay. Okay, so we have analog buttons. Let's do pull axis. Gamepad, left thumb stick. Okay, actually let's just do pull stick. X input state, gamepad. No, it should be pull axis. Okay. pull gamepad. So now I'm pulling all the gamepad stuff. Well, let's try some triggers. So this should test the thresholding logic and all the other stuff. Okay, so I'm getting pressed events but no release events. So was down. So I detect when it becomes greater than the threshold. But somehow the release is not working. If it was down and is no longer down. If it was not down and it's now down, then it's pressed. That worked. If it was down and it's now not, then... That was a little bit odd. Oh, I guess I don't even have something to print when it was released, so why the heck would I expect to see it? Okay. Alright. Pull axis, I guess, is the next thing. So there's a little bit of a... If I do... If left thumbstick x... so I'm essentially doing implicit comparison to 0, which means that if it's in the dead zone, it's a little annoying that I have to type dot value there. Maybe I should change how that's... Yeah, you know what? Let me do it this way. Since xinput already has a uniform threshold, I think this is better for the user, less typing. So rather than pull axis, rather than doing this here, pull stick guess we have to go and change that. So yeah, no more of this. And then do it like this instead. Finally, we don't need this junk. Okay. So now I'm not touching the stick and I'm not getting messages, but as soon as I hold it, yeah, so it's definitely thresholding. Just so we don't make it go apeshit. Okay. So that's holding it left. This is holding it right. This is holding it up. Okay. I guess I'm not doing up or down right now. So that makes sense. So it's overshooting ever so slightly. I guess... Oh, I see. It's because when I'm doing the division, I'm not taking into account that there's asymmetric min and max by 1. What's the easiest way to account for that? I wonder. So like... Actually, I know. So 3, there's some 32 division. So it goes from this. It's okay for the dead zones to be like that. Yeah, I think for these this is probably fine because an off by 1 there doesn't matter at all. But for pull, where I call pull, or a pull stick, I think I have to we add this, then we, okay, so that's, I should have known that. 65535. 65535. See, my math was all janky. So this is 1. This is exactly -1, so that's what I wanted. I know that was a little pedantic because I honestly I could just have clamped -1. I could just have clamped -1, but this is sort of the right way of doing it. So yeah. Okay. Includes rotation. You shouldn't, if you're doing rotation of collision, the normal way you would do that is by inverse transforming the thing you're colliding against and having the actual, like suppose you have pixel perfect collision, you wouldn't physically do a bitmap rotation of the collision map. You would just reverse transform the moving object into the unrotated space of the level collision map or something like that. Anyway, don't think I'm gonna go into stuff like that, honestly. It's a little basic and old school. All right, let's see if this still works. Left X, left Y, right X, right Y. Looks about right to me. So I think that's it for gamepad. I mean, we haven't tested all the buttons. I guess let me just glance at it. Up, down, left, left, right, right, left thumb, right thumb, back, start. Okay, so I'm going to say this is probably good. So what have we done and what are we lacking? I don't think I ever used float 2, did I? Let's just delete that shit. So far I don't think I've done anything with either sound or graphics, which is obviously, like, that's sort of the point. Yeah, I'm actually not going to do connected for now. Well, should I? Gamepad connected. I can't even remember. Let's see. Gamepad connected. Okay, so that's just based on X input get state. So by default is not connected, and then pull gamepad. If this is not, what is it? So what were the return values? Let's just do it like this. If it's not successful, then we set this to be disconnected and return. Otherwise, other way around. Okay. Okay, I'm actually not going to test the disconnected field right now, so I guess I'm going to have to, just because it means I would have to, like this thing is plugged into the back of my PC, I don't want to pull it in and out. Yeah, no, X input is universally held as like the best. Well, I guess Casey would disagree, but um, certainly in terms of like it's literally a one function API for the common stuff. I think there's one other function if you want to do like haptics, rumble and stuff like that. But just for sampling, this is all there is. By the way, Xinput has the potentially same issues as overall mu, which is um, if you call get X input get state at too low a rate, you can miss events. Now, one interesting thing they do is they have this packet number, and the packet number is like this incrementing thing, and you can basically inspect the packet number to see whether you missed any packets. And so even though you will still have lost the data, at least you know you missed something, which is you also see this in things like ETW and other fixed size ring buffer systems where it will fill up a ring buffer, but if the write pointer ever catches up to the read pointer and the buffer has to overwrite itself, it will basically set a flag to indicate the fact that it's sort of that you lost data. So even though you can't recover the lost data, at least you know that you don't have all the data. And so the packet number does that. It's sort of an interesting way of at least giving some metadata about undersampling. All right. Is this it? I don't feel like starting sound now, although, I mean, partly because testing sound with a stream seems insane. Some of us are going to get hearing damage, or if not hearing damage, a headache. So what should I do? I think this is pretty much it for the basics. I think the next stuff I would do to round out the API is sound. Fuck it, maybe I'll do sound right now. I'll do X audio or something simple. I don't even know. Like, the problem is with modern Windows Audio APIs, everything is built on Wasabi, but Wasabi is a pain in the ass to deal with directly. X audio is kind of easy to use, but it does a bunch of stuff you don't want, like the whole notion of mastering voices and submix voices and all this crap. Generally, all you do if you have your own sound mixing is you create a mastering voice and then create, is it a source voice, I think it's called, and then you just queue stuff onto this. What is it? X audio to mastering voice. Why am I not getting anything? Yeah, okay, let's do X audio. I don't think it should take too long to do something basic. X audio. Sorry about the background noise, by the way. I had to open the window because it was getting too hot. So if you hear airplanes and birds and stuff, that's from out there. All right, so okay, I'm trying to remember. Okay, so I guess we need X audio create. X audio 2 create. Okay. Actually, we don't even need to have a persistent field because we can just do this. Okay, let's see if that works. Seems to be null. Oh, it's a local variable, so I can't even really see it, can I? Okay, let's see. So is this thing? Okay, this thing didn't load. I guess it's not in the DLL, right? That's probably the issue. Maybe this one is only in the static lib and you have to do the COM stuff yourself. I mean, I can do that if I have to, I guess. Yeah. Do I have to do co-create instance and garbage? Do I have to go full COM? Going full COM is not normally something I'm fond of. Unknown outer class context. Let me look up these parameters. Okay, so null class context is like, what's it, proc, in proc? What is that thing called? class ID. No, that's not right. It's because this thing here is the reference ID. Yeah, so are you fucking kidding me? You can't use co-create instance anymore? Does this mean I can't dynamically load? Guess I'll just statically link it. Okay, I'm just going to be difficult. Because fuck this shit. Um, let's see here. So co-create instance. I thought the third one was a pointer to an I unknown. Okay. How can a GUID be? Okay. I'm sorry. I guess I'm gonna just use a loader lib. Fuck it. I was all ready to do some comm business as well. That sucks. Yeah, this is bullshit. So this is exactly why I wanted to do my own loading, because it's trying to find 2.8, but I already have like 2.0. What the fuck? Um, So you're saying that 2.8 and later you have to use the function, an inline function. That makes me wonder why. Um, Available only on Windows and later. Maybe that's if I use this, it's better. Is there anything called? No, there's. Why does it talk about Windows 8? I'm not on Windows 8 on this machine. What the fuck? Um. Oh, you're fucking kidding me. Does that mean I don't have the DirectX SDK installed? Or is it just that there's multiple headers and they're... Um, okay. I'm pretty sure I have DirectX installed, right? Okay. Oh, here we go. Finally some sanity, Jesus. So Xaudio create, you said you thought it was an inline function in the olden times. I see what you're saying here. Alright, that's better. So that should in fact just work now. If it's Xbox, else it's Windows. So why is it not hitting this inline definition here? There's too many fucking headers. I feel like it's still hitting the other header file. Oh, that's something else anyway. If Xbox, which is not true, so it should be hitting this. I guess I can do something like this. Yeah, so it's not even hitting this fucking file. Where is this file? So that's the one there. Why don't this include directory have priority? Oh, I guess is it? Am I reversing the order? No, I have to order it originally. There is no way that this other shit should take precedence. Like, even the IntelliSense shit itself is finding it. Do you guys see what the issue is? Oh, you're killing me. Thank you. Okay, thank God. Okay, here we go. Okay, so that succeeded. Let me just go get a drink. I'll be back in like a minute. The reason that got me, and this has gotten me like I don't know how many times in the past, is that the build configuration is not the default configuration when you go to the properties sheet under the project, which I don't know. It basically seems to have a persistent configuration it goes to when you go in there, which I guess kind of makes sense, but normally when you're trying to fix something in a project and you go to the project settings, you kind of assume that the two have some relationship, and they don't. So yeah. All right. Let's see here. X audio 2. How to play a sound. I mean, okay. Wait, don't you need a mastering voice? Oh, it's probably covered over there. Yeah, so you create a mastering voice. Okay. Actually, I need this handle in there too. Okay, I think already, and I will turn down my audio in anticipation of the complete mayhem to come. Although I don't know if you guys will be spared uh, the same onslaught. So we will find out. I guess let's see if this thing actually ran. This will fail because I didn't fill in the source format. Okay. The format tag. Okay, so that succeeded. I guess with some of this stuff we should clean up if it doesn't work. Okay, so the others don't actually have to be released, is what they're saying. Okay. Hey Juan, I think you missed almost everything. If you want to go back, I think maybe the interesting thing about this is less the implementation, which is standard, but some of the API design stuff, which is a little bit different, in that the whole API only has basically two functions, initialize and update. Update breaks into push and pull functions. Push right now doesn't do anything, but we're going to be using it in a sec once I get Xaudio to do something useful. All right. Submit using submit source buffer. The audio data which buffer points to is still owned by the app and must remain allocated and accessible until the step starts playing. Okay, so I think I have to do double buffering, right? This is where my eardrums get shattered, I'm sure. Okay. I think because it has this level of interaction with the queuing model, it can actually just play silence when nothing is queued up. Okay, I think probably I need to have some sort of double buffering action. What is this thing? Okay, that's a very large buffer. I don't think we'll ever be going that large. Queued buffers. Okay, so I assume what we have to do is we have two buffers, and when one of them fills up, then we kick it off. And while that one is being worked on, we fill in the other one. So when we've submitted it before it's been reported back as being done, we're not allowed to touch it because it's being read by the system. And then in the meanwhile, we can write to this other buffer. So I think that sounds like a plan. So I guess all of these are going to be fairly trivial. Like there's not going to be any loop points or anything crazy like that. Okay, I think. So maybe before we start writing the X-Audio specifics, let's maybe write sort of the generic, the overall, what the code would look like once it's done. So I think what we're going to do is we have samples between between sample buffer, well, that's what they're called. Copy to X-Audio2 buffer. Well, let's see. Something like this. Okay. So I guess one thing, detect if source buffer is playing. If voice started and has no buffers queued, the new buffer will start playing immediately. If the voice is stopped, the buffer is added to the voice queues and will be played when this voice starts. No looping. Can be reused if read after calling. Okay. I see. So there's a callback. Jesus, I fucking hate callbacks. Isn't there like a Windows event I can wait on? Why do I have to wait on a frickin'... And is this like a multi-threaded, like... Okay, so yeah, you're supposed to use set event. Okay, that makes it easy. So I will just do it that way. So I'll do that with an auto reset event, and things will be peachy. So I think this overall scheme will work. I think first off, if we don't have an Xaudio2 context, then we're just gonna skip. Okay. Buffer 1, so how much should this be? Max sound buffer. We'll see if it's like 44.1. This would be 1 second, which seems like way too much. If it's 10 milliseconds, it will be, which is too low. Let's do something like this. It's probably fine. So we're going to have this Windows event, which the callback will set. And into this we will have a cursor, which is what we've written. Well, actually, let's call that a count, samples count. And we will have a finished event. So we will have and then when we have some pointers to the same things, these are exponent, and this will be front buffer and back buffer. Unknown override specifier. I guess I can just do this. I guess in here we will also have this one. Let's call it Xaudio buffer descriptor. So the X-Audio2 descriptor. So flags is 0. Audio bytes. Actually, I can just do audio data. I guess at any given time, so this should start as 0, and then when we submit the buffer, we will update end to be the actual, I guess, length of data in there. Just plain length, not plain end. Loop begin. Loop length. Context to be passed back in. This will be the buffer. Okay. 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 Just make sure. Do I have an archive? You can always just go to the archive page on the Twitch channel. It should have everything. I don't upload them to YouTube, although maybe I should, but I haven't. Maybe there's an easy plugin to do that, but I haven't tried that, but maybe I'll look into that. Where was I? So I initialized these X-Audio buffers, and so in theory, all right, then submit. Where do you set the playback, or the callback rather? reset, nope. Initially not finished, and no name. I see. And then I voice callback. Cannot instantiate abstract class. Do I have to implement all these stupid fucking functions? Jesus. Okay, so there's an overloaded let's see. Default frequency ratio. Okay. So wave format 0 x audio 2 default. Okay, let's see if that still works. Okay. Okay, so in theory, if I look at push sound, you can do something like samples, well, samples written is this. And I think we have to write silence. So if samples, well, we can write it like this. Silent sample index will start at samples written, and it will stop at delta samples. So we haven't done delta samples before. Delta samples is mu delta ticks per second time mu samples per second. No samples per second. Is it sound samples per second? Yeah. Okay. Not a member of you. Okay. Delta sound samples. So basically the purpose of this is if someone didn't write enough, we have to write for them, essentially. Insufficient disk space. I don't even know what Marmalade is. I assume Marmalade is like the mobile game development SDK. I must have looked at it once upon a time for some reason. Anyway, okay. So if there's space, then we do that. Otherwise, and then we're actually done. Otherwise, we have to do two things. We first off have to copy the remaining samples to the front buffer, submit front buffer, and then copy, and then we do a wait for single object on the back buffer, finished event. This should be, I guess, infinite. And then no, we submit the back buffer, not the front buffer. So all the stuff I wrote here is garbage. It's back, not front. Front buffer is what's currently being rendered out of, so that one is off limits. For this one, oh, the thing that this doesn't do right is I don't multiply by maybe I should do it type def just so I don't okay. So if there is space, we just copy to it and then we're done. Otherwise, we have to copy as much as we can in there, then submit it. And submitting it, I guess, entails going to the source voice and saying submit source buffer. Back buffer X audio 2 descriptor. Okay, and this is the front buffer. And we have to make sure it's done. Once it's done, then we can make the, well, the front buffer will be the new, actually, this is too much indirection for the typing. Back buffer. So get the ground buffer. back buffer, new back buffer is the old front buffer. And vice versa. In theory, well, let's structure it like this just for consistency. I don't think it should ever be possible for mu-max sound buffer to be bigger than because of the way we chose things. Well, I guess it actually is possible. I think in that case we just have to wait. Does this mean we can't write very far ahead? And is that okay or not? Let's use the same number for both of these. But yeah, the way I structured it here, it will just block, basically. So how does it exit? I think this should be, yeah. So let's just read this. So we take the current back buffer, see how much space is left. If there's enough space, we just copy in our samples from the sample buffer and call it a day. Break out. Otherwise, we copy the we copy as many as we can into the back buffer. Let's see, we submit the source buffer, and then we wait for the front buffer to become available because it will be soon written to. And then we switch front and back buffers. Yeah, it seems, I think when I do my initialize X audios buffer, right now I say play begin, play length. I think I should make this max sample buffer. I should also check if that play length is measured in samples or bytes. Okay, this is samples, so that should be fine. Okay, in theory this is working now, but I think the chance of it actually working is very low. Let me go and reduce you guys' volume even further for system sounds, because otherwise if I make mistakes you're going to be very sad. Okay, I heard a click, the characteristic onset of audio. Well, the interesting thing about this is in theory everything is happening already. So like this should be happening. So an interesting question is what happens if there's too long between, yeah, like what happens if delta samples is larger than max, like the remaining sound samples buffer? That's a danger. Delta sound samples. If delta sound samples is greater than mu max sound buffer. Well, this Okay, so in that case, what will happen is just that it will essentially have a skip. Probably a good reason why you wouldn't want to do audio necessarily quite this way. You'd probably want to push some of this into a separate thread. Although even if you push it into a separate thread, I think the same overall logic would stand. It would just it wouldn't starve those buffers, at least at the Xaudio 2 level, even if they're starved at some higher level. Okay, let's see. Okay, onset click. I guess we should do some math to fill in. Well, actually, let's let's just write some code to generate examples. So for size t, yeah, okay. New delta sound samples. Let us do hacky. What was that? That was a uint64. It's probably excessive, but let's just do it anyway. Actually, I can do it that way. Time seconds. Okay, so what frequency? I guess 100 hertz maybe. The chance of this working the first time is basically 0. If you ask me to put odds on it. All right. And then divide by int 16 max. No, sorry, multiply. So Windows totally unresponsive. If I had to guess, it's hung on the wait event, or wait for single object. Yeah, so it's never coming back from this one. See if this ever triggers. Okay, so this does do that. So I wonder if, so F5 and now it's over here. I wonder what the, maybe that user data is all bogus. No, looks roughly correct. So the finished event is 168 in hex. If I go and look at N32X audio 2. Well, maybe just like that. Actually, let's just go and drill in here. If I go and look at front buffer, which is hopefully the thing we're waiting for. Okay, so I think maybe we're waiting on the wrong event. I see. So it's actually an initialization problem. We have to create event should have initial value, I think, which is the third. What is the attributes manual reset initial state? Right. So you want the initial state to actually be like this. Okay. Okay. Holy fuck. This is a sine wave generator. That's really farty, which is probably a bug, but let's crank it up a little bit. Yeah. Okay, so let's try turning that off for a sec. Okay, so it's actually completely, whatever's happening has nothing to do with my samples. It's probably just garbage data, like clicks, onset clicks or something that are being written in. So that would be good to understand. So let's just, so this should shut it up. Okay, so now it's not playing anything. And now it's playing whatever, it's playing whatever that is, okay. Let's look at this logic here. The delta between the current right pointer and this is equal to how many samples were written. I think that is correct. It then okay, so it does that and writes out any zero samples. Does this look right? Sound samples, delta sound samples. Then it tries to copy shit to the back buffer if it has enough capacity. And oh, I think that's the culprit. No, it was not the culprit. That was certainly a problem. Because that means the indexing was off. Well, delta samples was always reset. Oh, I have another thing. I don't think I actually set. Yeah, so there's, I know one of the issues, I think. Okay, so samples, I think this is just true in pull, probably. Samples per second should be, I guess, whatever we get back from this thing. And then in pull, we need to actually set this back to the beginning of the buffer. Okay, I'm gonna close the window. Those kids in the street are driving me nuts. I don't understand. Okay, I guess I maybe do. So we set this to the beginning of the buffer, and it looks like there's a memory scribble just like off the cuff. Okay, so now that the sound samples is actually being set the way it was supposed to, I guess the original code is doing something garbage. Sound samples per second. Let's see, what's the initial time? This is like the first iteration. No, it's not the first iteration. And this is all just 0, 0, 0, 0. I'm assuming if I take push sound out of the rotation, things are fine. And they would have to be. Okay. No, things crash. Because of a memory overwrite from that memcopy, I'm sure. Alright. So how am I doing that memory overwrite? So this should always be 0. If delta sound samples, well, let's try skipping this. Okay, so it's still push sound. So it's just from it's really just from that right loop there. Which suggests it's actually writing off the end of the array. Which is interesting, because this is what that lamp was supposed to handle. So I guess, let's see here. Okay, so samples written as 0, delta samples is like 3000, which corresponds to a little less than 1/10 of a second, so that sounds reasonable. Oh, sorry, let me do this to isolate that. This is such a simple loop. I must really be doing something stupid. Oh. That was pretty stupid. Okay. Okay, we're back to farting without the crashing. So these samples are all 0, as you can tell. Now we submit it, and the audio descriptor Looks like these are just pure clicks from the I wonder if it's because no, that shouldn't be it. Okay, let's maybe look at whatever their sample code was. If I do this, then I'm never filling anything in. It's still clicking. I wonder if it's a weird alignment thing. Jesus. Let's try that again. I am doing something stupid. I am never incrementing samples count. I'll just set it to this just to signify. So this is a garbage value samples. Pull. I thought I reset that. So this gets set to the beginning of the buffer every. Back buffer. Well, I guess maybe at this point things are fairly bad. So let's try this. So this has a lot of zero samples. Zero's a sample count of 0. That's actually not possible, is it? Oh. It's because there's a lot of samples. And this is a small number? No. If the capacity is less than delta, so capacity is this because there's actually no samples. No, it's the other way around. I am literally an idiot. Okay, silence without clicks. That's some sweet silence. Let's put the 0. Oh yeah, good stuff. Let's actually try doing this now. Okay, that doesn't do anything. I guess one way of, I should check, I should look at the buffer values when they come in here. Okay, so now it's never triggering. For totally different reasons, I suppose. Yeah, so that's a crash just because if we write actually, when we compute delta sound samples, we should clamp it at that point rather than doing it elsewhere, because otherwise users are liable to overwrite shit, and then they'll just get skipping if they happen to do it that infrequently. So if this is greater than that, then we don't have to do it here. I should also do something lower volume. Okay, it's doing memory rates. I think this is a sign I'm getting tired when I'm not able to just be clear on this stuff and just kind of bang my head against it. So maybe I'll look at it a few more minutes and I'll stop streaming. I think I've been streaming for 5 hours, so it's probably time to take a good break. But let's read this first. Actually, let's try skipping this first of all, just to take that variable out of the picture and see if that. Okay, so now we're back to clicking. I thought we were gone. I thought we're done with clipping. I wonder if some of the clipping is due to alignment issues, though. Like, if I did this, what would happen? Actually, let's make it a nice power of 2. Yeah, so it's just clicking for misalignment. Okay. Okay. That's some interesting noise. Oh, I see what you're saying. Yeah, that's really dumb. Okay, so here's how we're going to do it. Sample index, which starts out as 0. And samples per second. I think this part is right. Samples per second, delta ticks per second. Okay, and this fails. So regardless of what was going on, there's still some memory crap. I guess one of the interesting things is if I do this, oops. Mm. Okay. Hmm. Oh, that's a really dumb mistake. So once you have the back buffer, you have to reset the samples count. The event gets reset because it's an auto reset event. Wait, what did I just delete? Oh yeah. Fuck. Okay, I see one of the issues. Because we're going to do another iteration. Okay, I really need to stop coding when I'm just being stupid. Oh, we actually can't do it this way because we're going to copy the beginning of the buffer again. Unless we do... new sample. Let me copy from... Okay, I'm going to stop programming now because this is just... apparently my inability to do structured problem solving has gone out the window. So I think I'm done for now. I'm going to end on an anticlimax. I'm sure I'm going to literally solve this like 5 seconds after closing the stream, but I need to do quite a lot in like 5 hours or however long I did this shit. So yeah, I hope you guys, I don't think there's anyone who was there from the beginning, but appreciate you guys hanging out. So I'll probably be back later with more stuff, including working sound and working graphics and maybe other things like I think of. So yeah, thanks for hanging out.